kindly find a seat, we're just about to get started. So get comfortable. You too, Pranav. All right. All right, welcome everybody to Datapalooza. Really, really good to be here. And how cool is it that we've come from all corners of the world to be right here together in this amazing, chaotic city. How many of you here are visiting Bangkok for the first time? Oh, very nice. Okay, okay. Raise your hand if you traveled more than 6 hours to get here. Okay, all right. More than 12 hours of travel? Okay, okay. More than 24 hours of travel? All right. Let's clap for the people who traveled that long. I mean, probably very jet lagged. Just so you're aware, there is coffee outside. I hope you got some. And for those of you that did not join us in Istanbul last year, raise your hand if it's your first Datapalooza. All right, so we're in this together because it's my first one too. All right, so I think now's a good time for me to introduce myself. My name is Brian Berman, and I'm the product marketing manager over at a company called Edge&Node, which contributes to the graph. For those of you hearing about the graph for the first time, the graph is a decentralized protocol that makes it easy to organize and access blockchain data. And today is all about data. So you'll learn all about the exciting, nerdy things being built across the Web3 data ecosystem. And in addition to the graph, we were joined by folks from places like EigenLayer, Flashbots, Aztec, Dune, and the Ethereum Foundation. So you'll want to stick around to hear from all of them. And we have experts that work with oracles, privacy, data availability, infrastructure, and more. It all comes back to accessing data and how that data powers everything that we do in Web3. Lots of exciting stuff on the lineup before all the craziness of DEF CON begins. So when you're done with all the partying of this week, it's the end of the week and you're coming back to work hungover, Datapalooza is the perfect excuse when your boss asks, hey, why did we expense your trip to DEF CON? So I promise I'll stop rambling soon, but I just wanted to leave you with one more thought. The Ethereum Foundation has a vision for the Ethereum ecosystem, and it's called the Infinite Garden. It's inspired by a quote by a professor named James P. Carse, and I'll read the quote to you. A finite game is played for the purpose of winning. An infinite game for the purpose of continuing the play. What we're building in this ecosystem is human coordination, which is more like a garden that needs constant care than it is a game to play. Tying it back to data, many have called data the new oil, but I'd argue that data is more like water. It flows through every layer of the Web3 stack, nurturing growth from L1s to infrastructure to user applications and beyond. And on that note, I've got to keep this thing flowing. So real quick, some general housekeeping before we get started. Bathrooms are outside, down the hall. You can find water in the back of the room or out there too. A delicious lunch will be served at 12:30 p.m. for an hour. That takes place over here on the 4th floor and also one flight down on the 3rd floor. And in the afternoon, we'll have a dual track. So we'll have talks in this room. And if you want to get your hands dirty and start building something, we have a workshop room right next door. So, you guys ready to get started? All right. To kick off our day of data exploration, we have Sam Green from the Cambrian network speaking about the network effects of verifiable data. When we talk about watering the infinite garden with data, verification of data is like ensuring the purity of the water source. Like, what's in that water? Is there fluoride in the water? Like, I'm talking about that report that Mark Andreessen shared the other day. Anyway, Sam's a great friend of mine, and he's been contributing to the graph by ways of semiotic, and now he's cooking up cool new things at Cambrian Network. So I'm pretty excited to hear what he has to say. And unlike excess fluoride, Sam Green's talks have actually been proven to increase IQ. So let's put our hands together for Sam Green. Let's go.
Okay, thank you. Good morning, everyone. Give me just a second to set up. I don't need audio. Can we switch display? Thank you. All right. Thank you for being here on the first day of DevCon with me. This is probably going to be you're going to have the most energy of the whole week right here and right now. And I appreciate you being here with me for that. My name is Sam Green. I am a founder of Cambrian Network, and today I'm going to be talking about the network effects of verifiable data. Previously, I was a co-founder and CTO at Semiotic Labs. Semiotic is one of the core dev teams in the Graph protocol, and they're focused on verifiable data, AI, and on-chain payments for the Graph. Semiotic also previously incubated Odyssey.xyz, which is the #1 DEX aggregator in the Ethereum ecosystem. And they incubated Cambrian Network, which I left when we spun it off to lead. Cambrian Network is a blockchain for providing verifiable data to on-chain agents and to smart contracts. And it's built on the Graph. And I'll come back to Cambrian later in the talk, and I'll talk more about how Cambrian interacts with the Graph later. So the focus of this talk is about network effects. And the definition of network effect is that a product has network effects if the value of the product grows when the number of users using that product increases its value. Sorry, I'll just read this. A product has network effects if the value grows as its user base grows, or when different types of users join. So there are two types of network effects. There are direct network effects, and direct network effects are when the value of a product grows when just the number of users grow. So Facebook is an example of that. The more of your friends that were on Facebook, the more valuable Facebook became. And the second type is when different types of users join. Those are called indirect network effects. And I'll give an example of indirect network effects in a moment. So Ethereum, actually before I go on, I should say that a product can't just snap its fingers and guarantee that it's going to have network effects. Founders always hope they can build something that will have network effects, but it's no guarantee. It's actually, you have to wait and see, did your product achieve it? Ethereum is a product that for sure achieved network effects, or has network effects. So for example, when Uniswap joined Ethereum, it brought in many new users and lots of liquidity to Ethereum, and that increased the value of interacting with Ethereum. And this was proven because of the fact that many new projects came to Ethereum and started actually composing on Uniswap just because of Uniswap's presence. So that is, and that brought more developers and more liquidity. So that's an example of direct network effects. So specifically, if we think of in that DeFi context. I would argue that L2s, the existence of L2s, is an example of indirect network effects for Ethereum. L2s users aren't executing transactions directly on Ethereum, they're executing on the L2s themselves. But the L2s depend on Ethereum for security. And the L2s aren't just like passively using Ethereum, they're also promoting the existence of Ethereum. You may have seen a few weeks ago the ETH is the ticker meme that was going around on Twitter, being tweeted by L2s themselves. And all of these users that I just mentioned are not likely to switch to another L1. So network effects are often sticky. All right, so now I'm going to transition into talking more about how the Graph has network effects. But before I do, I'm going to talk about the Graph itself. So the Graph makes all blockchain data accessible and queryable by providing composable, verifiable infrastructure for decentralized applications. Oh, and if you want these slides, I have a link to the slide deck at the end of the presentation, so there's no need to take any pictures unless you want. At a high level, the Graph organizes blockchain data. So if you look at any blockchain, let's say Ethereum, it's continuously emitting blocks. These blocks have all sorts of information about the smart contracts being executed by the blockchain, and the information is not organized. The blockchains themselves are not responsible for organizing the blockchain data. That's what indexing is for. So the graph takes all that unorganized data and it makes it organized for developers and consumers to use. I didn't appreciate Brian's contradiction to the oil analogy for data, because I'm going to use it. I recently moved to Texas, so I like to bring up that fact every time I can. And I'm going to actually use the oil analogy with the graph. So oil gets turned into many different products. Here are just some of them. These are actually mostly fuels. But actually, petroleum is also the source for many medicines and plastics and thousands of products that we're using every day. Similarly, for the graph, information, there are actually thousands of different information-oriented products that are possible. Within the graph, the blockchain data itself, the unorganized blockchain data, is the raw material. And then indexers in the graph, the indexers are basically like the graph's validators. They do a lot of work, and then they process that raw data, which then gets turned into many different products. At the lowest level of our stack, there's Firehose. So Firehose is the lowest level of the graph's product stack. Then we have substreams and subgraphs, which is somewhat processed data. And at the top, you have basically applications, dapp front ends, Geo, dapplooker, token terminal, Masari, and Tyco are some examples of products that are basically derived from this raw blockchain data. And in general, if you look at the Web 2 data market space, it's gigantic. And there are hundreds or thousands of different data-oriented products. And all of these products actually could be built on the graph. And today, we only have a handful of these products built on the graph, and I expect to see more in the future. So this is I'm going to show the data flow or the data pipeline of our current products, of the graph's current products. At the beginning, you have basically indexers who are running either archive nodes or full nodes. Then there's a piece of software called GraphNode, which is maintained by the graph. And the GraphNode exposes basically queries for GraphQL for data. So GraphNode organizes blockchain data, puts it into a database, and exposes the ability to query that data. That data is then queried by dapp front ends. So we have many or most of the major dapps use the graph subgraph data for their front end use. This particular product has had a lot of traction. Earlier in the year, the graph completed the sunrise, which was basically shutting down all centralized infrastructure. Now the graph, all of the data on the graph is provided by the decentralized network, and it's doing really well. Last quarter, there was a 75% increase in query volume. So last quarter, there were over 5 billion queries served. There is also a Firehose-based stack in the graph. So when you think of the graph right now, think two stacks. One, the original stack, if you've ever used the graph, or if you used it in the early days, was subgraphs. There's another data extraction stack that's based on a product called Firehose. With Firehose, you have indexers run a full node. The full nodes then create these archive files. Archive files are complete sets of the history of a blockchain. Those archive files are then processed, or those archive files can then be used directly and ingested into custom data warehousing solutions, or they can go through another product that the graph builds called substreams, and substreams can sync to many target destinations. So here we have a bunch of databases. So the Firehose-based stack is a very customizable flow of data. And I'd like to just point out that I'd just like you to pay attention to where the archive files sit in this flow, because I'll be referring to the archive files more as the talk goes on. So you can see that it's very close to the source of the data. It's very important for all downstream use of the data. If the archive files are bad, then the downstream applications are going to have bad data. I'll come back to that. Okay, so that's actually what I'm getting at there is I'm starting to get into verifiability. So verifiability means the ability to check or demonstrate that something is true and accurate. So it's kind of a vague term. In crypto, there are different types of verifiability that are popular right now. On this basically axis, on the left-hand side, we have techniques that are faster to implement and easier to use. And on the right-hand side, we have techniques that have better theoretical properties, but they're harder to use. And my belief is that there's basically, you should always use the right tool for the right job. I don't believe that you should use, for example, cryptography or ZK for everything that you possibly can. And so, you know, if we look at what's happening right now in crypto, I'll go through these quickly. TEEs, this is a technology that's being basically adopted by Flashbots and Uniswap. TEEs are basically used engineered security. Basically, you have to hack. You have to be a hardware hacker to break a TEE. I spent about 5 years of my career with a top, I think we were a world-class team focused only on hacking TEEs. And these things are incredibly difficult to break, and especially when you start combining things like economic security on top of TEEs. These are, in my opinion, these are great solutions. And if we go to the right, we have consensus and voting. This is something that like Chainlink uses these techniques. And we can see that Chainlink's data secures a lot of TVL. So consensus and voting, in my opinion, it works great. The problem is if you have a fault or if there's a problem, it can take time to actually figure out what went wrong or if someone was at fault. Then we have optimistic methods and fraud proofs. I would say that the graph actually fits somewhere in between consensus and voting and optimistic methods for its verifiability. And we can see that the graph has been working great as well. And then finally, we have validity proofs, ZK, and cryptographic solutions. And I want to point out that even though the cryptography has the best theoretical properties, that whenever you actually implement cryptography, there's basically an unlimited number of ways for things to go wrong. And so one thing I'd like to just kind of point out, this is not really related to this talk, but just for everybody, right now I'm talking about, there's a lot of narrative about these technologies. Things become hyped, and people start hating on some of these technologies. But I'd like to point out that cryptography can go wrong so many ways. I also worked on that for many years. And just because it's mathematically secure doesn't mean that if it's been implemented that it's secure. In fact, it's probably not secure. That's usually my initial assumption, that a new cryptographic implementation is wrong. And historically, we've seen it happen over and over again. But at the bottom line is there's the right tool for the right job, and these all have places. I believe that in the future, the graph is going to end up deploying products using most of these verifiability techniques. I am particularly interested in using cryptography for some of the lower level data in the graph. The reason is that, in particular for the archive files that we create through Firehose, I would like that data to be cryptographically verified, because I think it's worth going through the effort and the time and the complexity to get that data correct, because then other people downstream can use it in a trust-free way. So there are many products that are being built on the graph today that use these archive files, and by the graph ecosystem, making sure that all of the blockchains, all the popular blockchains are supported by Firehose, all the popular blockchains' data is cryptographically verified, what it's going to do is it's going to support the most number of downstream applications that can be built on it. And some of those downstream applications may have different methods of verifiability when they're going to ingest the raw archive data, they're going to do stuff to it. They may use other methods to verify that their processing was done correctly. If you'd like to see more about Semiotic's work on verifiability, there are 2 links I have down here that go into details about how the graph is approaching cryptographic verifiability of its archive data. So I'll quickly give a high-level overview of how Semiotic's approaching Ethereum data. Every chain has a slightly different, has different consensus mechanisms, and so their data is totally different. And so each chain is going to have to be studied, basically, by the graph. And the graph is going to have to figure out how to actually cryptographically verify the data coming from each chain. The graph has started by focusing on Ethereum data. At a high level, the archive files contain all of the blocks that were generated during the processing of the chain, so it's a complete chain history. And the verifiability approach for Ethereum is that the epoch roots are recalculated. So basically, an indexer, to verify that they have the correct data, will take the archive data, they will read all of the contents, they'll recalculate all the hashes in the archive data, and then the final value is called the epoch root. The final value for each epoch root is then calculated and checked with respect to an external source of truth. So specifically for this approach, we are checking with the Portal Network, which is an Ethereum Foundation effort it's an Ethereum Foundation effort for creating archives for the Ethereum history. And so by doing this, by basically recalculating all of these hashes, an indexer can then calculate each epoch hash, check it with respect to the Portal Network, and then know that their archives contain the exact information that the blockchain saw. So yeah, there's more details at those links below. So to me, the most interesting thing, and a very interesting thing about cryptographic verifiability that's implemented correctly with no bugs, is that then the data can be used for more critical applications, specifically for on-chain applications. I think, if we look at, let's say that if we were to use optimistic methods for the archive data, to just optimistically use the archive data and then take that archive data, do something on chain with that archive data, and then after the fact have to raise a dispute about what was done, then this could lead to loss of funds. And so this is why it's important to have absolute knowledge that any sort of data you're doing logic with is perfectly correct. I'll give some more examples in a minute if that's not clear. And this is what brings us to Cambrian. Cambrian's sole purpose is to provide trusted data to on-chain agents and smart contracts. And it's going to be built on the cryptographically verified data that the graph generates. At a high level, you can think of Cambrian as a decentralized data warehouse that provides a SQL query access to on-chain agents or smart contracts, which will then, if it provides it to, let's say, an on-chain agent, that on-chain agent will then make blockchain transactions, execute blockchain transactions based on the historical data that it may be doing decision-making from. That information or that transaction will then go to some target chain, which will generate more data, and Cambrian will index it and prepare it for querying in the future. So some of the features of Cambrian are that it will have omni-chain support, so not just Ethereum and L2s, but it's going to support Solana, Bitcoin data queries. Every major chain will be supported. It's going to have standard SQL support. It will be very fast, and it will be verifiable. This is where Cambrian sits in the Firehose stack. So you have Cambrian builds on Firehose. It's a consumer Firehose. And basically, it wants to consume these cryptographically verified archive files and then be able to do its thing with it. In a little more detail, Cambrian will have a peer-to-peer network where all of the validators in Cambrian will run the Firehose stack, and they'll have databases, and they'll populate their databases from this raw archive data and basically be prepared for on-chain queries. And then it will be able to send the data back to the destination chain in transactions. We've been working on these techniques for quite a while, and one of the first proponents of bringing off-chain historical data, using off-chain historical data for expanding smart contract capabilities was Ethereum. So, sorry, it was Uniswap. Uniswap has a new AMM design called Uniswap v4. Actually, I half expect them to announce it being live on mainnet tomorrow, but we'll see. The cool thing about v4 is that Uniswap wants to become a platform for AMM designers. And so v4 is going to be it's a very flexible thing for designing AMMs. And one of the interesting things is they've designed this thing called hooks, which lets you bring in off-chain data into the rules of the AMM. And this will let AMM designers do something like give discounts to whale traders. If you were to try to do something like that with just smart contracts, you would have to keep history of all of your traders' activity within your smart contract, and this is impossibly expensive to do. And so you have to be able to bring in off-chain data to enable something like that. We built a demo that uses historical data to calculate the recent volatility of the price of Ethereum on Uniswap mainnet. We then take the prices, and we use those in a customized v4 hook. And the idea is that when the volatility of a token is high, the trading fee should be a little bit higher. And when the volatility of the token is low, the trading fee should be lower. And so, yeah, so this was a demo that we made for using Cambrian and Uniswap v4. Okay, so that's a high-level overview of what Cambrian is. Now I'll come back to the graph. So Cambrian will have its own validators. Cambrian will buy Firehose data from the graph protocol. It will also sell Firehose data within, Cambrian's validators will also sell Firehose data within the graph protocol. And in general, Firehose, Cambrian's validators will be Firehose-based indexers within the graph protocol. And I'm not saying this just because I want them to do this. Historically, working in the graph, what we've seen is that validators or indexers, in the case of the graph, will always try to be as economically efficient as they can be. And so if Cambrian's validators are already doing this hardcore data processing, indexing all this blockchain data, maintaining these Firehose archive files, that is a ton of work. And so for them to be able to basically become more economically efficient, it'll be very easy for them to be more economically efficient by reselling that data in the graph protocol or participate in the graph protocol. So that's what I expect to happen. Okay, so at the beginning of the talk, I said that you can't just have network effects by default when you make a product. You have to build your product, launch it, and see if you achieve network effects. And I believe that the graph has strong network effects. So for example, there has been developer demand for subgraph composition. Basically this, historically, when subgraphs were created, let's say you made a Uniswap subgraph, if that subgraph didn't have the capabilities that another developer needed, they would have to build their own Uniswap subgraph and do it from scratch. And developers have asked again and again, hey, I would just like to be able to use what was already created and modify it just a little bit. So the graph, that sort of demand implies that the ecosystem, wants that capability. And if that capability existed, then the more subgraphs that exist, the more beneficial it would be to all users. So I think that's an example. We also see that many new projects are launching on top of the substream stack. The one that The most recent one is called Tycho. It's out of PropellerHeads, and it's basically provides DEX data. And so here we see this. I looked at this Tycho project a little bit. It seems to be a new type of use of the graph. And then we see Cambrian. Cambrian I think Cambrian is a completely new type of product being basically built on the graph. Cambrian represents a new type of user. So this would be specifically an indirect. Well, Cambrian has two effects. It has direct network effects for the graph and indirect. The direct are that Cambrian validators are going to consume directly from the graph. And Cambrian validators will also provide the graph's data. So it's like Cambrian's validators will basically be increasing the number of existing users using the core protocol and improving, I believe, the core protocol because of the resources that it will bring and consume. And secondarily, Cambrian basically views the graph as an L1 for data. Cambrian is basically Cambrian is not supported by the Graph Foundation, and it is just this totally new type of product that we want to use the graph for its existing capabilities, and we think that the graph will continue to exist cycle after cycle. And so, yeah, so I think that this is a secondary effect, just using the graph in a way that it wasn't originally designed for. Yeah, so that's all I have. If anybody would like to talk about any of these topics, please find me after this talk or follow me on Twitter. Thanks, everyone. Oh, this is the link to the slide deck if anybody wants it. I'll leave it up for just a few seconds. Oh, yeah, sorry. Yeah, I think we have plenty of time for questions.
Hey, how's it going? Thank you for the talk. It was very good.
Thank you.
What about, if I understood correctly, right, your decentralized processors are taking data from the archive files, and the archive files, every time there is a new block, they need to rehash everything for it to be verifiable. How does that affect latency?
Yeah. So the whole archive doesn't have to be rehashed every time. Once you get up to chainhead, it's at least for Ethereum, it's an incremental thing. So you just have to calculate the hash of the most recent block, which will take milliseconds.
Awesome. And then from your decentralized processors, how much time do you expect for them to be able to synchronize and take the new data from the archive file until you can query some new data that came on the latest block?
Yeah, I think that at least for Ethereum, it will be sub-block. It's going to be a sub-block latency, and the goal is for every chain that we support for it to be sub-block. Some chains don't have like fixed blocks like Ethereum, but fixed block lengths like Ethereum. But our goal and belief is it will be able to be sub-block within the milliseconds range.
Cool. Great primitive.
Thank you.
Really awesome talk, Sam. Thank you so much. Really excited for Cambrian to come to the network. Question is, if the graph provides validity guarantees on the archive files that Cambrian consumes, what is your strategy for propagating those data verification guarantees down to the query?
Yeah. OK, so the way that I see this happening is that Cambrian's validators will get the archive files, and they will each Cambrian validator is going to have to maintain its own set of archive files. It's going to have to do the work. Or it'll either have to buy it and then stay up to chainhead, right? So the first step that the validator will have to do is verify that their archive files are correct, and keep that verification running as the chain progresses. Once you have knowledge that your archive files are correct, you know that the data that you're working with is the same data that the chain believes exists, right? So now you have a data set you can work with. From there, we're going to transition into economic security and consensus protocols. So a validator will then extract from the archive file, a Cambrian validator will extract from the archive file, and let's say they're maintaining a database with some sort of rolling aggregation, like let's say they're maintaining the total value traded or the total amount traded by some user in some protocol. So anytime that needs to be updated, they will update that database, the entry with that. Then when there's a query for that data, all of the Cambrian validators will query for that make that particular query and run a consensus protocol, maybe something like Tendermint, and make sure that they all agree that that's the result that you should have. So those are the steps. The lowest level data is cryptographically verified. Then there's a transition into using economic security and consensus protocols.
Makes sense. Thank you.
You're welcome.
Quick question, but thank you so much for speaking. I'm really excited to hear about Cambrian. I was just wondering what kind of front-end dApps you think would benefit the most from that would be built, that would benefit the most from Cambrian?
Oh, okay. That's a good question. So I don't think that dApps, I'm not trying to, actually, it's not that I'm not trying to, but Cambrian's going after, it's a different data product. dApps probably won't use Cambrian. dApps will continue to use the graph's existing solutions, or the solutions that, because I was recently a core dev, the solutions that are coming in the near future. I think Cambrian is a new type of product, and so it's going to have different types of users. I think that the way that I think about this is that we're targeting smart contract consumers and on-chain agents. So smart contracts today, they don't have any access to historical data. They don't have any access to be able to make database queries and make decision-making, do any sort of business decision-making based on historical user data. It's just not available to them. It's too expensive for them to maintain that. And so what Cambrian does is it basically provides smart contracts with this new capability to be able to say, hey, what was happening in my protocol or this other protocol or this other chain, and I want to modify my logic to adjust to that. So this is a new user type for the graph. Similarly, the other type are there's an emerging on-chain agent market in, I would say, segment in crypto. Most of these are DeFi related, and they're doing things like DeFi trading. And some of these are going to be very simple agents, and some are going to be complex agents that are trying to do, like, say, historical analysis before making their decisions. And so we'll be able to provide this sort of data to them, too. And the reason both of these applications, all this verifiability that I'm talking about, both of these applications need high verifiability because money, at the end, if we're talking about on-chain applications, there's usually money at risk, and so there's very little margin for error.
Great. Thank you.
Thank you.
Hi. Thanks for the presentation. I had a question. What is like the new use case that you unlock or you are most excited about, besides from the on-chain agents, like for smart contracts?
Well, let's see. I mean, right now, I think that I've covered it, because right now I think that if we look at what's happening in crypto, we have our incumbents. They've been around for cycles. For example, Uniswap. The incumbents are exploring a little bit. so for example, V4, where they're bringing this allowing you to bring this off-chain data on-chain, and they're exploring with these new designs. And then we see some of the other incumbents like SushiSwap and PancakeSwap following them and doing the same thing. They're starting to explore with bringing off-chain logic capabilities in. I think that if they show success with experimenting with these sorts of features, then I think all major protocols will follow them as they try to expand their features and be competitive. The reason I think that the agent protocols are more interesting is because they're more exploratory right now. People are trying a lot of stuff in that space. They're not incumbents. There are no incumbents. And so they want to try to find something that works, and they're very, very eager to explore new things. And so that's why I'm targeting them. That's been an emerging market. But I'll look at both. I'll continue to try to build relationships and see if we can build something for the Uniswaps and the incumbents that are experimenting, and then also work with these the emerging agent protocols.
I have a second question. If you deploy a smart contract or an on-chain agent that uses your protocol, you would deploy that contract on another chain, right?
Oh yeah, good question.
And how would you verify that the data from your chain comes to the other chain and is still correct?
Yes. So we're not an L2. The architecture looks more like it looks more like how Chainlink works or decentralized Oracle networks work, where the verifiability itself is all contained within Cambrian network. So all the consensus happens there, all the slashing happens there in that network, and because of that, what this lets you do is you can then Cambrian network, because it's built on the graph, which is monitoring all chains. Cambrian network, by definition, is also monitoring all chains. And so what you can do is you can receive a request for data from chain A, and you could deliver that data on chain B, or at chain A could request, your smart contract on chain A could request data from chain B, and you could bring it. So you could do, that's how you can do it.
Thank you. Just expanding on that previous question, so I was just curious about how does the on-chain agents consume your data? It's sort of like an Oracle service that you also offer, right? Who writes the data?
Yeah. So we're still trying to explore what the best, or maybe we'll have different mechanisms for doing it. What we've built right now for that Uniswap demo I showed was that there was an on-chain transaction that had a query for data. We then monitor and we see that transaction happened, and then we make a transaction putting that data back on chain, basically through a callback function. Mm-hmm. So that's one way. Another way that we can do it is an off-chain API request for the data. So an agent protocol could just make let's say a micropayment using, let's say, a payment channel off-chain, call our API, ask for the data. We return it with, we basically return it with a verification with a signature that they approve, and then they use that data however they want, whether they want to put it directly in their contract or if they want to ingest it in their protocol.
Yeah, still being finalized then?
What's that?
Still being finalized, like a couple of approaches.
Could you say it one more time?
Yeah, so the approach is still being finalized. It still hasn't been. So Cambrian is not using proofs. So by the time that data will basically be returned from the Cambrian protocol, it will already have gone through consensus within the protocol. Yeah. Cool. Yeah, makes sense.
Thank you.
Probably follow up after that.
Hey, one more question. What about, for example, if I want to have some processing mechanism of the data, custom, right? How does it work? How do I upload it to nodes? And how do nodes choose which processing mechanisms to run? Do they run all of them? And one more question to that, how do they charge? Do they charge by processing time or by queries?
Yeah.
Because I could have heavy processing or light processing, right?
Yeah, great questions. Okay. So are you familiar with DBT?
No.
Yeah, so one way, so I don't know yet, but one way we could do it is allow developers to specify DBT that they want done. And once they specify DBT, we can then price it. So the protocol can price it. This is challenging, but we've spent, within the graph, we spent a lot of time thinking about how do we measure these sorts of costs, because it's very similar for the subgraphs and for substreams. So yeah, one way is expose DBT during, basically a developer is going to be like, oh, I want this data from this chain, I want this data from this chain, I want to do these sorts of computations on this data. It's very similar to how Dune sets up. You know, Dune has a very similar DBT flow. And so then they register their DBT, and then the indexers pick it up, or the validators pick it up, and they start basically maintaining those views of the data. In the future, we may be able to have some sort of WASM, more general computing that we would include. But right now, we're just going to focus on the database aspect of it. And if more logic is needed, then we'll partner with one of the other decentralized compute projects out there.
Awesome. Thank you.
Thank you.
Awesome. Thank you, Sam, so much. And thank you all for the lovely questions. Always love hearing from you, Sam. Here for Sam. You're so smart. Appreciate it, Sam.
Thank you.
Yeah, I'm sorry, Sam. Unfortunately for your love of oil, I am sticking to the water theme today. Sorry for that. Okay, next up we have Markus Schmitt from PropellerHeads. PropellerHeads have been solvers on CowSwap, Uniswap X, and 1inch Fusion. Last week, they've shifted their focus on decentralizing the trade supply chain via open sourcing tooling. So Markus's talk is titled Towards a Decentralized Trade Supply Chain with Better Access to DEX Liquidity. And I promise you liquidity was not a water pun. All right, let's hear it from Markus.
Excuse me? No, I don't need sound. Well, let's see if it comes up. Yeah. Oh, I know, I just need the mirror. But we're just gonna do the hacky way. Okay. Great. Well, testing in prod. Hey, everybody. So I'm Markus from PropellerHeads, and I mostly do all the product planning and research there. And if you don't know PropellerHeads, we've spent the last 2 years in this little corner of DeFi that is very often abstracted away in the solvers are going to take care of it. So this is exactly what we did. We've been building solvers over the last 18 months for CowSwap, for Uniswap X, for 1inch Fusion, and for many others who were using our APIs. And we've spent much of our time wedged between two very prominent parts of the DeFi trade supply chain, which is the liquidity, all the DEXs, but not just the DEXs. Also, the lending protocols, the stablecoin protocols, the restaking protocols. And on the demand side, all of the solver auctions, the wallets, the traders, HFT traders, anybody who wanted to trade and execute a trade. Now, both of these are very, very well known, but solvers, I think, often abstracted behind a box. Solvers, searchers, they're going to take care of it. I'm going to break open this box a little bit today because I think it's important that we look into how this DeFi trade supply chain is being built and why maybe, if we're not careful, this DeFi trade supply chain will centralize and then have rippling effects on everything that we build in DeFi. And to give you some empathy for what it is like to be a solver, one of the most important parts for solving, and also the hardest parts, is to integrate all of the different liquidity sources. Now, it might seem so simple, right? There's all these public interfaces, and I can easily check their code and then integrate them into my solver, and then I have my smart routing algorithm that figures out if you want to do a big trade, should you be trading on this curve pool or this balancer pool, or maybe should you be splitting over them? The problem is that none of these protocols are standardized. Everyone implements their curve math and their interfaces differently. And so as a solver, we and any other solver, we have to go and understand the internals of every single protocol. And this is the equivalent, more or less, of understanding what the developers understood when they developed these protocols. Why? Because every tiny bit matters when you simulate swaps over protocol, right? And many of these are completely customized on different pools. So there isn't one balancer. There are four or five different balancer pool types, and they're customizable, which means there's an infinite potential number of pool types. And for curve, similar. There's not one curve. There's 3 different versions, and then there's 12 different pool types. Integrating them is really, really a lot of effort. And it's not just indexing what I need to know to simulate, but also knowing how I simulate. What many solvers do is they go in and they replicate the entire curve math. And by curve math, I don't mean just curve, but the trading curves of all the protocols inside their own Rust re-implementation so that they can efficiently simulate these protocols. Again, this only works if you understand every single little thing. And if you miss one hard-coded variable somewhere, you will error, your trade will not execute. And finally, solvers need to execute. And execution is really also not that straightforward, because you need to handle users' assets, and you need to handle them safely. And if you don't, you can really easily, during the execution, either lose your trader's assets or yourself be exploited if you approve against the wrong contracts in the wrong way. Also, you need to build an execution contract against every single pool type and against every single DEX that you want to integrate. And just a reminder, if you don't do this, you have no chance to have a business, because you are in direct competition with all other solvers and all other searchers who are competing over the same order flow. So if you miss a crucial protocol, you will not win that flow that needs that protocol. And if you miss a significant portion of all of the existing DEXs, then you will not win any flow in those competitive auctions. And this means that just to start, you are forced to go through all of this and spend a lot of time in order to catch up with the incumbents and get some flow. And only then do you actually earn cow rewards, do you earn on your trades, and then you can grow your team. But the longer the incumbents exist and the more DEXs there are, the harder it is for you to catch up. The harder it is for you to make your first buck, or you land your first searcher bundle, land your first one auction on CowSwap. And while I want to get a little bit more into the indexing problem, why specifically is indexing so messy? I think we've talked a lot about this today, so I'm going to go over this pretty quickly. Indexing by querying the nodes through JSON RPC calls is ridiculous. It is like having an API interface to an SQL database. Why not just talk to the database directly? Well, because we don't have that interface. And as I just said, all of these things, they add up to a massive barrier of entry for solvers, but also for searchers, also for market makers who want to trade on-chain, right? Don't forget that competitive market making on-chain depends on on-chain execution. You can't just access off-chain liquidity like on Binance. You also need to access on-chain liquidity to be a competitive DEX arbitrager. And for that, you also need to have all these integrations. And for the whole ecosystem, it's a big pain because every single solver team re-implements this code. And I think a conservative estimate is we have 20 of those teams. I think we probably have more than 100 who have done this effort. And not a single one of them is incentivized to open source any of this because it is their competitive advantage. Now, is this a problem? I mean, it's a lot of added effort, and it's hard to get into this game. Maybe it should be that way. I think it is a problem because it leads to centralization. We see this today. Market makers are centralizing more and more. There are fewer and fewer players winning larger and larger parts of the flow. The same is true for searching. The same is starting to develop for solving. And we just recently, 2 months ago, we tried to help a new solver enter CowSwap. And it was extremely hard, and they gave up after a month and a half, seeing that the effort to become a competitive CowSwap solver on mainnet is simply too high. And this, I think, is going to start to happen from now on more and more, that we will not see new solver teams unless we change something. But again, maybe having an oligopoly is also not that bad. Why do we need decentralization here? Is decentralization absolute good, or can we live with this type of centralization? And I think we actually cannot, because ultimately the promise of DeFi is that not just the state and the chain is resistant against censorship and is decentralized and permissionless, but also that everything built on top of that chain, specifically the fundamental building blocks like swapping, are permissionless and you cannot easily censor them. And this is no longer the case if the actors in the trade supply chain centralize, because the reality today is that you don't interact with DEXs anymore. You do not. You interact with solvers and with searchers and with market makers, and they are the middleman between you and the actual DEX. And no matter how decentralized the DEX, if the solver in between is centralized and they are told to censor you, then you will be censored. If the market maker in between is centralized and they decide to extract egregious fees from you, then you will be paying egregious fees. And this will then start to look uncannily a lot like TradFi, where you have incumbents that capture the market, that ossify around their technological advantage, and then increase the fees and extract, and are also very susceptible to censorship. Now, this is why I care, and also because on top of trading, we are hoping to build and move a lot of the world economy, and this will not fulfill its promise if we don't make sure that the trade supply chain stays decentralized, and therefore censorship resistant and efficient, meaning low fees. Now, how are we doing? How can we possibly do this? And I think the simple answer is that we need to simplify the jobs of all of these actors in the trade supply chain. We need to make what they have to do easier so that more people can enter and more people can sustain a business, and they don't have to have a team of 20 people to be a participant in the trade supply chain. Now, today, we're introducing Tycho. Actually, we published this a week ago, but you're probably the first to hear about this publicly. And Tycho is a tool built on substreams in the graph to index, simulate, and execute, and make all of these parts easy. And I'm going to talk a little bit now how does Tycho do this. Also, before I go further, Tycho is entirely open source. Every part of Tycho you can inspect and run yourself, MIT licensed, and you can reuse it as you wish. And you can build on top of it whatever you like. Now, I mentioned these three parts, and I want to go over them now individually. Like, how do you solve this indexing problem? And I think the indexing one is the one we know the most about, because we've heard about this a couple of times now, that it is ridiculous to ask a node for every single piece of data that you need through RPC requests. So Firehose and substreams make this extremely efficient by instead inverting the process and streaming the data to you. Now, Firehouse has geographically distributed nodes that all race to provide the data. And then in substreams, we can define mapping modules and processing modules that process the block stream into exactly the pieces that we need for solvers. And then we stream them in real time to the solvers, so that you never need to query for the data that you need to search, to solve, to market make. You get it streamed constantly after every block. And this is extremely fast. I think we are averaging less than 100 milliseconds between the latest block and you getting the entirely processed data locally. You can also do this in parallel, right? If you do historical syncs and you want to build the state of, for example, Uniswap v3 with tens of thousands, maybe even over 100,000 pools, then you can go over the entire chain history, index all the pools that were generated, index all the ticks for them, and do this in parallel, which if you didn't have parallel processing, as far as you would wait for months to do this. And now you can do it in hours or days, index large protocols. And then we store this in a database, easily accessible. So solvers themselves don't need to run databases anymore. And then we can give snapshots of the historical state, plus, as I said before, all of the real-time stream of the updates from the current blocks. Now, this makes it super easy for any solver to onboard, get all the state they need for the protocols and the DEXs they want to swap over, and then continuously consume in low latency the updates that they need to solve. So this is the indexing problem. Now, we also have simulation and execution. Simulation is an extremely hard problem, as I said earlier, because all of these protocols expose different interfaces. This morning, we published ERC 7815. I mean, we got our number this morning. And this is an interface standard that we developed together with auctions like CowSwap and other solvers and searchers to capture exactly what a solver needs in order to simulate, like the price derivative, the amount out function, the swap to price function. These are things, I'm not going to go into detail, that you need if you're running, for example, convex optimizers over DEXs in order to find the optimal route. By standardizing this, we're giving all of the DEXs, not just the current ones, but also the future ones. Today, tomorrow, maybe, Uniswap before we go into production, and there will be many, many hook teams, each looking to get flow, each looking to get integrated in solvers, and they will have a very hard time to integrate into solvers if they don't comply with a standard that makes it easy for the solvers to integrate. This is something I didn't mention earlier on the centralization part. It's not just the participants in the trade supply chain, like the solvers and the searchers, that are threatened to centralize. It is also the DEXs. If you are a DEX and you just launched, and no matter how good your design is, you have the chicken and egg problem of attracting liquidity into your pools and attracting solvers who integrate you so that you can get order flow in the first place. Almost no DEX today gets flow from their front end. They get the flow from all the routers, all the solvers, all the searchers that integrate them. And if they don't integrate you, you have no flow. And if you have no flow, you can attract no liquidity, which means that centralization and high effort to integrate centralizes also the DEXs, because as a new DEX, you have almost no way to bootstrap unless you have very large LPs who are willing to give you money before there's any flow to speak of. And solvers will not prioritize your integration if you don't have any liquidity. You can circumvent this if you implement a standard that you know that all solvers use and that you know that all solvers understand. For the solvers, it's a single integration into a single interface, one time. And the DEXs can proactively comply with the standard, and it also works, it's also backwards compatible. You can deploy an adapter and make this compatible with any DEX integration that exists today. And this allows the DEXs to innovate and more DEXs and more hooks to come on the market, because it's much easier to bootstrap flow. And this is absolutely impossible today, and one of the most urgent problems of DEXs. So standardizing the interface to DEXs fixes the simulation problem. And then we have the last piece, which is the execution problem. And last week, again, and it's not the first time, a solver got hacked because of a new adapter that they deployed to a new DEX, and their approvals got abused, and they lost. Luckily, not that much, but if it wouldn't have been noticed later, as early as it was, then the loss would have been much, much higher. I think they lost like 50K of the Cursor pool. And as I said earlier, building a router and building those adapters is a dicey endeavor, because if you make mistakes, you're risking the auction protocol and the user's funds. And what Tycho does is we have adapters and routers implemented together with the DEXs for every DEX, and each of those adapters and the router are audited by a third-party audit. This way, you can now use and execute over DEX Liquidity as a solver without having to build, gas optimize, and check the security of your own router and adapters. And yeah, one thing that also maybe is underappreciated is that solvers, as I said earlier, are under high pressure to integrate new DEXs, because this is how they make money. Integrating a DEX earlier means you win flow that others can't win, so you're constantly incentivized to risk funds in order to integrate new protocols faster. Tycho completely eliminates this incentive by having DEXs integrate into Tycho before they even launch, meaning you have absolutely no advantage by jumping hoops. The adapters and DEX integrations are audited before they go live. This way, there is no more incentive to raise and risk user funds. Now, I said earlier, the goal is to simplify all of these 3 steps, and I just showed you how that works in Tycho. Now, what does that give us? If we have simple indexing, simple simulation, and simple execution, then we enable all of the upstream implementations to be much lower effort. So as I said, solving will become much lower effort. I think single-person teams can realistically do it. The same goes for searching, like backrunning, or writing your own liquidator if you're a dapp for your own protocol, writing your own OEV capture if you're an Oracle, building a price oracle on top of DEX Liquidity also becomes much easier, because you no longer need to interface with all the DEXs. You can use a single interface. And then on top of that, that enables intent protocols to bootstrap themselves much more freely over many more chains. Today, it is extremely hard to find solvers. And unless you are on mainnet, and unless you already have a big brand, you have no solvers that participate in your auction. But if you make it extremely easy for solvers to build, and for you to provide an open source example solver for your auction, then you have a much easier time to bootstrap a solver ecosystem for your auction. And the same goes for capturing MEV revenue as a sequencer, or even building trustless open source solvers that anybody can use and doesn't have to rely on the solver being a good actor. So having these things simple enables a whole set of open source and simple to implement use cases that then enable the intent ecosystem, I think, that many are building towards. Now, I already mentioned Tycho. If you go to PropellerHeads.xyz, you will see under products Tycho, and you can learn more about it. Where we are today is the Tycho indexer is live, and you can use it. Tycho simulation will go live in the next few days, and Tycho execution will probably come in a few weeks. I actually, if we are lucky, can do some demo. So, where's my mouse? OK. Nope, this doesn't work. Here. So here, this is So here we are running locally the Tycho client, and the Tycho client connects to the database that indexed all of the different DEX protocols. And what's happening in the background now is we're downloading a snapshot of all the state that you would need to simulate over any of these protocols, Uniswap v2, Uniswap v3, Balancer. And then it continuously listens to updates from every block. We're not going to see the updates of the blocks here because that's not what this interface is optimized for. But what you will see is a preview version of Tycho Simulate where you can simulate now over any of these DEXs. So these are the pool addresses. And if you go, for example, what are we going to do? Staked ETH. That's a simple one to understand. So this is, I think, a Uniswap v3 pool that we're going to see in a second. And we can now do real-time simulations over this pool. I'm just increasing the amount here. And you can see how long it takes. It's 8 microseconds to simulate over this pool. Now, you don't need to know anything about how the Uniswap v3, this is the Uniswap v2 pool, how it's implemented, how to simulate, how the curve math works. You simply just query amount in, and Tycho takes care of all of the calculation and the state management in the background. And this is based on real-time data from Ethereum mainnet. And you can do the same thing with thanks to Alan, he's here in the third row. He built this in a day 4 days ago. Now, if you want to run this yourself, what you just saw, you can go to GitHub PropellerHeads Tycho simulation, and there in the examples, you can run this same example and get exactly the same result in like 2 minutes. So if you take your laptop out, you can do this right now or anytime. And you can also then modify this for whatever purpose that you seek. Now, yeah, I invite you to start building on Tycho. You know, if you are a DEX or anybody who has liquidity, stablecoin, vault liquidity, lending liquidity, anything that you want to get flow for, anything that you want solvers to use so that you have more usage on your liquidity, you can use Tycho. You can integrate today. Go to the docs page. I post in a second. If you have any sort of application where you want to route over DEX liquidity because you want to index, simulate, execute over because you are a solver, a searcher, a builder, a sequencer, because you are an auction, or because you want to build an intent protocol or Oracle, you can use Tycho today to index, simulate, and execute over on-chain liquidity. Yeah. And if you want to know anything more, reach out. That's my Telegram. You can just write me directly. Yeah, happy to answer any questions.
Thank you so much, Markus. Thank you very much. I think we have time for just one question. So I'll put the pressure on you, Markus, to pick somebody raising their hands.
Hi there, amazing talk. Thanks for outsourcing and publicizing the solvers. I'm actually with Curve Finance, and thanks for memes. My question is, what are the major pain points and how can we make your life better from the DEX side?
Can you pass the mic to Alan?
So basically having like one interface to swap or like to compute basically marginal prices. And if you look at the adapter interface that is public on GitHub now, basically exposing this or implementing this for your protocol, it makes the life for all servers much, much easier.
All right, thank you for that question. Thank you so much, Markus. Really appreciate you joining us today. I don't know about you guys, but all this nerding out is making me hungry. But before we jump into lunch, just a couple quick reminders. Food is served on the second floor. I didn't mention that the first time, I'm sorry. It's served on the second floor, but if you don't find space there, you can still get food on the third and the fourth floors. But I'm told the second floor is the nicest one. Just a reminder, after lunch, we're running a parallel track, one here where the talks and panels will continue. And I remind you that the workshops take place right next door. So we have about an hour for lunch. Workshops and the next talk start at 1:30. Come back here 5 minutes before 1:30 for a talk from Flashbots. We have Elaine joining us from Flashbots. And if you want to go the workshop route, Kevin Jones from Edge&Node will teach you how to build the subgraph in the workshop room. All right, thank you guys so much. We'll see you in about an hour. here is just about to get started. But if you are here hacking and excited to build your first subgraph, I do remind you that a workshop is taking place right next door. So if you're here to build, that's the room. Kevin Jones will teach you how to build a subgraph. So just give us a couple more minutes, and we'll get started with the rest of the afternoon with talks and panels. So stay tuned. No, you speak. All right, if everyone could please take their seats. We're about to resume. Hope you guys are feeling good after lunch. Coming up next, we have here on the main stage, Elaine Hu from Flashbots. Flashbots, in their own words, like to illuminate the dark forest that is MEV, which, as you know, stands for Maximal Extractable Value. Elaine is here to educate us about order flow dynamics with her talk titled Balancing Exclusivity and Sharing Strategies for Ethereum Block Builders. So let's put your hands together for Elaine. Let's hear it.
Okay, welcome everyone. First session in the afternoon. Hopefully you had some nice lunch, caffeinated, feeling refreshed. Not too relaxed though, because we have a lot of interesting stuff to get into. So order flow dynamics. I'm going to talk about the exclusive order flow, and especially for the smaller market share Ethereum block builders, the dilemma they face today between keeping their exclusive order flow to themselves and sharing them with bigger block builders. So we know that today, the top 2 builders build around 90% of the blocks, and we know who they are. As a smaller builder, if you only build, let's say, 1% of the market share, you can calculate this statistically. So it takes around 7 blocks for all your transactions to be landed on chain. So for some users, this might be okay. They don't mind waiting for 7 blocks to land. For the others, this might be too slow, right? So as a block builder, you want to satisfy your users. You want them to land their blocks quickly. So you have to share some of this order flow to the top builders. We all know that the key to win blocks have many components, and I'm just listing 4 of them here, which I think are important. First one, algorithm. Your block builder has to be very good at algorithm, ordering the transactions optimally, build them quickly, so then you can build a very valuable block. It also has to be very quick, right? So taking the latest bundles you receive, combining them into the block, building the block quickly, sending them quickly to the relay. You also need to know how to bid strategically. You don't want to show your hand too early, too fast. You also don't want to be waiting for too late and bid too low. But the last one, exclusive order flow, is probably the most important component out of these four, right? Because imagine if somebody sends you a transaction, a very valuable transaction, and he only sends it to you. And you can use this transaction to build a block, and the block is going to be so valuable that no one else will be able to compete with you. So even you are very crap at algorithm, you're not the fastest builder in the world, you don't even bid strategically, it's still likely you land this block, right? Because nobody is able to compete with 100 ETH block that you receive this valuable transaction and put them into the block. But the reality is, it's very difficult for someone to know if the order flow is exclusive, especially for smaller builders. Why? Because as you can see, the users, including the searchers, the wallets, individuals, they tend to send order flow to different block builders because they want to guarantee their transactions will land fast enough. They don't trust one single builder. They don't want to put all the eggs in one basket. And among the builders themselves, they also share order flow, right? As I mentioned, as a smaller builder, you want to share order flow so your users can land faster. So I'm going to show a specific event. So during the 4th, and between the 4th and the 5th of August, we've seen Ethereum prices dropped $1,000. So this triggered a lot of massive liquidation events. And I picked up some of the high-value blocks. So these are all blocks that's over 50 ETH. And you can see some of the builders are listed under here. And it's around 30 blocks. And in the next session, I'm going to choose randomly 3 blocks. And I'm going to ask you to guess who landed this block. Of course, by providing you some information first, we're going to look into the block data. So, for example, how many transactions are in there, not who built the blocks, but how much the proposer received, what's the profit of the block. And then I'm going to show you the relay data to see how all the builders inside the slot bid, and in the end, what's the amount they bid to win. And lastly, I'm going to use some very confidential data from Flashbots to check if internally the Flashbots builder have seen these order flow. The idea is that if we've seen the order flow, then it's very likely it's not exclusive to the winning block builder, right? Because we are one of the top 4, top 5 builders. If we've seen it, it's likely someone else has seen it. So this is a guesstimation. Okay, first block. No cheating, don't look at Etherscan, just see the information I provide you and see who produced this block, right? So this block has 161 transactions, and you can see the builder has received 202 ETH. The proposer received 202 ETH. The builder made a profit of 176 ETH. So very high value block, and the builder also made a lot of profit. And looking inside the block, right, 161 transactions, we can see most of the value lies on top of the block. So then I had a look at libMEV's data. The top transaction is labeled as a liquidation bundle. And this bundle is worth 155 ETH. So that contributes to the majority value of the block. Now, checking against Flashbots Builder, I have 4 categories here, right? So on the left-hand side is just the count of transactions. Right-hand side is the value of these transactions. So public means we've seen this in the public mempool. Builder transaction means it's a direct transfer to the builder, so less likely to be any kind of MEV bundles. Private seen means that it's a private transaction and the Flashbots builder have seen it. Private unseen means that we haven't seen it. So if we haven't seen it, that's more likely to be exclusive to the winning builder. And you can see that most of the value lies inside the private unseen transactions, right? So you can see 21 transactions are worth 220 ETH. Although there's still some value for the private seen, which means that the 11 transactions are most likely shared between some of the top builders. Okay, lastly, how do they bid? They tend to bid very closely, right? So the winning bid is 202 ETH. The top bid is 212. Second top bid is also 212. So they bid very closely, trying to win this block. Now let's have a guess. Who won this block? Any idea? Shout if you know. Beaver? OK. Yes, you're right. Unfortunately, I don't have a prize. So Beaver won this block, and most likely others also have the same order flow, but just Beaver is very good at bidding. They're very fast as well. OK, next one. This one, very different. It only has 27 transactions inside. So usually you have around, I don't know, 150, 200, 300 transactions inside a block. This block is not optimized. It still has a lot of space left. And the proposer gets paid 201 ETH. Builder made a lot of profit, 255 ETH. Looking at the transactions, we see the most value lies in the middle of the block. Again, looking at LibMEV's data, a liquidation bundle again, right? Extracted value, 359 ETH. The majority of the value lies in this bundle. OK, now this time, checking the Flashbots builder. We haven't seen any of these private transactions. The 7 transactions that are worth 456 ETH, we've seen none of them. So more likely, exclusive order flow just to this builder, right? So how do they bid? The top bid is 203 ETH. The winning bid is the second bid, which is 201 ETH. But if you can see, it's a bit small. The top bid is exactly 2 ETH above the second bid. This is very unusual. If you strategically bid, you would not add exactly 2 ETH on top of each other, right? You have some algorithm, you bid in a percentage or whatever. It's not like just exactly 2 ETH. So this looks like someone is brute force bidding on this. And you can see there's a lot of profit. So probably they don't mind just adding 1 ETH on top, 2 ETH on top, because there's still so much profit left. Order flow-wise, same thing. Unseen private transactions, 7 transactions. There was 456 ETH. So most likely, exclusive order flow to the winning block builder. Oh, sorry. Next. So now, have a guess. Who won this block, given all the information? Titan? This is a tricky one, right? It's unknown. So this is a liquidation bot, which we didn't recognize before this event. But during these 2 days, this liquidation bot has built a lot of blocks. And it seems like they only build blocks to capture the liquidation MEV opportunity. Right, so we can only identify this block builder by their pub key, which is 0x83b. And you can see, go back on the days between 4th and the 5th of August, they built a lot of these kind of blocks. OK, next one. So this one, similarly, 36 transactions. The block is not optimized, still a lot of space left. The proposer got 62 ETH. The builder had a profit of 102 ETH. Not as much as before, but still very profitable. Looking at the transaction value, again, the top transaction has the most value. And this time we look at Sorella Labs data. This is categorized as an atomic arbitrage. Right? So most of the value of the block comes from this one transaction, which is an atomic arbitrage. Order flow-wise, again, same story. Flashbots builder haven't seen these 6 private transactions. There are 30 public transactions inside the block, but the 6 private transactions are worth 165 ETH. So now the bidding is quite interesting. You see that the top 3 bids are kind of similar, and the 4th bid is suddenly dropped down to like 21 ETH. So there's a huge gap between the 4th entity and the 3rd entity. But even if you look at the top bid, which is 79 ETH, it's quite far away from the second bid, 75. right? And the winning bid is 62. So the top bit and the second bit are quite far away, which sometimes means that they're not chasing the same opportunity, or the order flow is not exactly the same. And the other interesting thing is the winning bid is only 62, and this block proposer picked the block at 8 seconds, which is very early. Usually, people play the latency game. If you have heard about latency game, timing game, people pick at the end of the slot. So if this proposer knew better and played this latency game, he or she would have won 79 ETH, right, rather than 62 ETH. Okay, now have a guess who won the block. So it turns out to be EigenHash block. So this builder is not a very, he doesn't have a very large market share, but whenever EigenHash block build blocks, they tend to build very high value blocks with very few transactions inside. So they also build a block just to capture their own MEV opportunity. They don't trust anyone else. They just want to build this block so they can capture the opportunity. They don't share their order flow. Okay, so we've talked about these three cases. First case, most likely the order flow is shared among the top builders because the bids are very similar. Second case, exclusive order flow. They're competing. There are probably people competing for the same opportunity because the first bid and the second bid are exactly 2 ETH away. The third case, they're probably not competing for the same opportunity because the bids are very different, right? Even the top bid and the second bid are like 4 ETH away. Usually, you don't see people bid so inefficiently unless the content or the order flow inside the block is very different. So is there a way for a smaller builder to tell what is exclusive, right? Usually, it's very difficult, but it's possible that you check the past transactions and figure this out. So if I check who sends me order flow in the past, and have I seen this entity sends to other people and they landed their their transactions. If not, then it's likely they only send to us, and I'm going to prioritize them. I'm going to land their transactions exclusively. So if we can look at the history, and we could build something maybe to predict, right? So I tried this approach in the past to try to predict if our builder will land a block. And if the probability of our builder landing the block is very low, then we're going to share this order flow, let someone else land the transactions for our users because we have no chance of winning. So here's an example. I used 3 days of data. It's very data intensive because for every slot, every builder has to produce hundreds of blocks, right? Many simulations. So 3 days data is probably 20 million rows of data, a lot of data. And I include in the calibration some of these factors like what's the top bid from all the relays, what's the bid that our builder has produced, and what's the timestamp of these blocks when they were built. And I throw them into this model. You can see, you can build a decision tree, right? You can see what are the rules and to decide, when should I multiplex. But there's also a way that you could try to optimize the model by minimizing your false positives. False positives is just the way that you trying to predict, but actually trying to predict something that to be on chain, but actually it didn't land on chain. So if this number is too big, you are overestimating your winning rate. If this number is too low, which is the false negative, then you're being too conservative. So you try to find a balance between these two and customize your threshold. Although we have this method, but it's not very good, right? Even though it produces a statistical way to predict, you can tune them using confusion matrix. You can change the decision, calibrate them pretty regularly, right? Every 3 days, every 1 day, whatever. But it's data intensive, and the calibration is heavily skewed because as a smaller builder, you have a binary event to forecast, your land on chain sample is going to be significantly smaller than your not land on chain sample, right? So for anyone who builds classifier, you know there's an unbalanced class problem that you have to use some technique to handle. Also, the results are sometimes very volatile. It gives you a tree, a decision that doesn't make sense at all. And lastly, you're only training this locally, which means that you don't have other builders' data. You're only training on your own builders' data. It's not going to be accurate. So is there anything else we could do? We have all these intents. We have the smaller neutral builder who wants to just land their user transaction quickly, maybe win some market share. We have these searcher builders who want to land their MEV opportunities. I kind of categorize them into three. The neutral builders, they don't care. They just want to win market share. Their order flow are likely to be shared. The searcher builder who wants to capture the opportunity probably don't want to share order flow either because they're competing with the other searcher builder. And then last one, you have this one that probably two different builders, they're competing different opportunities. So in the current world, they have to compete and outbid each other to land a block. But in reality, if they knew somehow their opportunities are not conflicting, they can put these bundles in the same block without reverting. So they don't have to outbid each other and pay the proposer an enormous amount. They can just collaborate, right? That's the ideal solution. So there are some ideas that we've thought about internally in Flashbots. I don't know what's going on. Right, so, okay, back. Yeah, so the first one is that, I still have 1 minute. The first one is that you design something that's a second price auction. So you can say that there's some kind of invisible coordinator who will pay the difference between first price and the second price. So your builders or your bidders don't have to overbid. They just bid their true block value. And whatever is the difference between the first price and the second price will be refunded back to the winning block builder. Or the second case, you're not competing for the same opportunity. You just want to combine them together to build a very valuable block that can satisfy everyone's needs, and then you are very you are very competitive compared to the other blocks. So you win, and then you can refund back whatever the winning block value is and the second best bid, because you just overpaying a little bit of the 21 ETH to win, right? So you don't have to actually pay 25. So internally, we've been thinking about all these ideas. Maybe we could have a decentralized block building. Many parties build blocks jointly inside a trusted execution environment where your privacy is preserved. You don't have to review your opportunities, but at the same time, you can share your order flow, coordinate the bids. And then, as I mentioned, with the second price auction, you can get some refunds, so everyone's better off. Okay, I'm running out of time. Stay tuned and come brainstorm with us. If you have ideas, talk to me. Thank you very much. Question? We don't have time for questions. Okay, one question, if there is any. Yes.
Regarding the machine learning model, did you filter on like high value blocks only? Because you said you had 2 days of data or 3 days of data, and that was a lot already. But wouldn't it make sense to like filter out only the blocks that actually have high MEV value and use that data only to predict? Because it doesn't really matter if your block has low MEV value if you land it or not, right? Or it's less important at least.
It's actually the other way around, because to win market share, you have to win the smaller value blocks. So we care about, like when I build this model internally, we care about increasing our market share. So most of the block is worth less than 1 ETH. So actually you have to include those with lower value in the calibration. Yeah.
Because otherwise you will never get the high value ones in.
Exactly, and we're not able, because Flashbots builder is a neutral builder, we don't search, we don't run trading strategies, we're never going to be able to produce that kind of high value blocks. Yeah. Okay. Thank you.
Elaine, so much. How many of you guys got at least one of those questions right? Nice, good job. I got none of them, so I'm hoping to get a little smarter by the end of today. All right, moving on to the next panel. The next panel's title sounds like a story from the Chronicles of Narnia. It's called The Oracle Odyssey, Trials of Trust and Truth. This panel brings together 3 visionaries across the Oracle and indexing spaces. We're going to hear today from Matt Gerbiel from Redstone, Niklas Kunkel from Chronicle, and the panel will be moderated by Emanuel Schmitt from Edge&Node. Please put your hands together to welcome our panelists.
Hello. So, how is everybody? Do you have fun? Do you learn stuff here? I learned a lot already. Yeah, welcome to the panel. So it's about oracles. So today I learned that oracles, I mean, it's a Greek mythology. And I always thought that oracles on-chain are a bit a weird name because by myself, I thought oracle is something or someone that you ask to know the future, whereas oracles on-chain usually talk about the past. But both are allowed, it seems. So that's what I learned. Let me introduce, so we have Nick from Chronicle Labs and Matt from Redstone Oracles. And usually I ask the participants of the panel to introduce themselves, but I actually want to ask to introduce each other. So like, what do you like about the other protocol? So maybe we start with Matt. What do you think does Chronicle very well?
Sure. Hi, everybody. Matt from Redstone here. So if I were to describe Chronicle, I would definitely say that this is, some of the OG guys from the Maker Mafia, if you can call it that way, in the sense that you would use for example, the PayPal Mafia, right? So a group of very entrepreneurial-minded people that happens to be clustered around this very, very important protocol back in the day, which was and still is MakerDAO. So, a lot of very strong engineers as well on board from Poland. I'm from Poland, so we know some of these guys that work for either some of the Maker protocols or Chronicle specifically. So the engineering power is there, that's for sure. The tech is already battle tested, and they have been on production for years. They have been serving Maker as a service provider basically for years as well. So definitely the reliability aspect is there as well. And right now, what we see most is their angle when it comes to real-world assets. So as you guys remember, Maker used to have, or actually still has, this kind of a dual engine model where the yield comes either from the on-chain sources, the on-chain native yield, or RWAs. And it works well because in the bear market, the RWA or outside of crypto yields get more exciting for the protocol, more profitable. So that's where Maker makes the most money in the bear market. And then when it comes to the bull market, it's obviously the yield that comes from DeFi, which is the greatest. Then you have innovations such as Athena and other types of yield. But in general, I think the model stays intact. So now Chronicle, as we see, does have quite a lot of I would say, focus on RWA's aspect specifically, and just tapping into that market, which is probably going to be big. So more or less, this is how I would describe Chronicle as we know it from a competitor's perspective.
Nick, what do you think about, how would you describe Redstone?
Well, this is not how I expected today to go. I thought we were going to come up here and have some kind of battle, not be complimenting each other. But no, I think there's a lot of good things to say. I think you guys have a really, really strong team, both on the technical and on the business front. It's incredibly, right, I mean, we've been doing this for many, many, many years, but it's incredible to see how you guys went from 0 to 1, like in such a short period of time, right? You built multiple products, right? You were quite early on the Polar Oracle front, right? Right back when, right, it was really just Pyth at the time, right? But since Pyth was very Solana focused, right, you really seized that opportunity, right, to, in combination with, right, integrating, I think, chains extremely quickly. And so you were able to carve yourself out like a significant like market share in DeFi, right? Really with a, like almost like a brute force, force of nature type of capacity. And so, you know, it's as a competitor, right? It's sometimes frustrating, but as a business person and as a technologist, right? It's pretty inspiring to watch.
Okay, that was very nice of both of you, but let's now switch faces and be not so nice anymore. So, Matt, what do you think are the flaws of Chronicle? Where is like, what's not good about Chronicle?
Right, so the way I would approach this question is, you know, what kinds of, I guess, pain points we see in clients' conversations in general. And the thing is, also for you guys to understand, we over at Redstone, we do have quite a lot of focus when it comes to being present on a lot of ecosystems. And this was kind of the design philosophy as well behind the tech. So the tech is built in a very modular way, so you can switch different components, you can add new ones for redundancy or for the sake of being able to launch quickly on new chains. And this is, I believe, something that Chronicle does not have currently in terms of I'm not quite sure if this is exactly the, you know, a product-specific thing or a focus-specific thing, but it seems to us like Chronicle is focusing on just a handful of chains, the strategic ones, the big ones usually. Now, this might be either you know, a good or a bad strategy, depending on how you believe the multi-chain world is going to play out. For us, we believe that there is going to be quite a lot of chains coming. There is going to be a strong power law distribution between them, but we want to be exposed to as many of them as possible, right? So what I assume Chronicle is better for is actually serving the existing big chains, because maybe the deployment on new chains is just more complicated, or, you know, maybe it's just the tech is just not fit at this stage that it is right now to be like, you know, wildly available and day one present on the new chains that come live. So probably this would be the biggest flaw, I would say, from our perspective. So if you were to apply our strategy to Chronicle's product and focus, this would be kind of a clash here. And that is strictly because we don't really see Chronicle that much when it comes to the new and upcoming chain conversations, whether this is L2s, L1s, and things along that nature. I believe if I were to put a hypothesis on it, and Niklas, tell me if this is, you know, true or not. So how I would describe it is, you know, we came to the market way later than Chronicle did. So we were able to actually, you know, build the product itself, all of its components around this hypothesis of being present on as many chains as possible, of being very modular in nature. We call ourselves strongly a modular oracle. And the way it works, all of our price feeds are kept off-chain in a decentralized cloud. And in order for us to launch on a new chain, we don't have to redeploy the infrastructure. We just plug the cloud in, and everybody can just use those prices. So maybe the hypothesis here for me would be that Chronicle, this is just a tech that exists for many years now, and it was built specifically for Ethereum mainnet with the premise of Ethereum being the main thing in the long run, and maybe that was sort of the design philosophy, maybe not super fit for the, the abundance of L2s, abundance of private block space, abundance of app chains that are coming online. Now, Niklas, tell me if this is true or not.
Yeah, please defend or attack back. Up to you.
Sure. I think we probably have a different strategy, right, in terms of product and in terms of business strategy, right? And I think from a technical capability, we can absolutely, right, deploy on any chain relatively quickly, right? I think just sometimes deploying to a chain that doesn't have any activity is just kind of nonsense, because it can be kind of a waste of time, right? You integrate a chain, you deploy there, you now maybe you spend some resources to integrate, but really what's more important is the opportunity cost, right? You could have been doing something more productive during that time, right? And so I think one strategy is to attack, right, all the newer chains, right, and be the first oracle on there, and maybe by default, if they get some traction, right, you are now the king of the sandbox. But I want to touch on, right, this power law distribution you were talking about, right? I do think that the bigger ecosystems will become bigger, right? So the arbitrums and bases of the world, right? Liquidity begets liquidity. And if you're going to launch something new, you're going to launch where the liquidity is. Now, you can, I think, if we re-enter a bull market and people start doing kind of token farming incentives, and someone announces we're going to do $500 million of incentives over the next, 6 months, right? Then, yeah, you can get a ton of liquidity right at once. But I think that's a bull market only type of strategy. That's not a general strategy that you can always follow. I mean, in terms of like criticism on the Redstone side, I think one of the strongest pieces of Chronicle is kind of our validator network. So we use a network of validators which are kind of the top crypto projects in the space, right? And it's projects like Infura, like Etherscan, Gitcoin, Gnosis, DYDX, ETH Global, Nethermind, Mantle, right? And so the idea is that if you get kind of all of these highly reputable projects, right, to basically attest to data, then the kind of likelihood of a kind of consensus dispute, becomes, almost like non-existent, right? Or becomes highly improbable, because there would be like crypto cannibalism. It would be like the industry turning in on itself. And so I think that comes with costs, right? And one of the costs is that when we want to do like an update, right? We need to get all the validators to upgrade, right? And so you need to be like, hey, you upgrade, hey, you upgrade, hey, you upgrade, right? And they're like, okay, we'll get it in the next sprint, right? And so I think that kind of cuts down on our agility a bit, but I think it gives us much stronger guarantees from a data integrity point of view. Versus with you guys, right, what we've noticed is I think you guys were just running your own validators for the longest time, which seems strange, because what is the point of validators if you're just running all of them, right? Like, you can always agree with yourself that the data can be anything you want. So I never really categorized you guys as particularly trustless or decentralized in that kind of way. But I do see the benefit of like going with that at the beginning to like scale incredibly quickly, and then substituting out that kind of validator network with something else, right, in the future. And I believe that's kind of what you guys are trying to do with this AVS on EigenLayer.
Yeah, so a couple of things when it comes to decentralization, I believe. So the approach that we've had was very, very product-facing, and it still is, which means the thing that we had to optimize for, as you said, basically was the speed of updates, the speed of iteration to be able to be quick to market as quick as possible. But then the decentralization aspect is definitely interesting, is definitely important on, I believe, 3 main verticals. One is data accuracy. So if there exists a true market price, how do we get the closest to the true market price? Then censorship resistance, right? So if the regulator can kill the company, if it's like possible or if it's not possible. And then I would say liveness is the third component that's very, very important. And I believe that if you have this kind of a product approach, when it comes to data accuracy and liveness, especially at the early stages of building a product, it's just way easier to maximize for these 2 parameters while being, rather concentrated. So either running your own validators, all of them, or just having like a, very closed circle of 2-3 partners that you do it with, just because you get to tweak the tech way quicker. And there is a hole that you have to solve, and the update just gets, out there, and it's super, super, super quick. But when it comes to, the regulator potentially able to kill the company, that's where I believe we need the true decentralization, and that is something that we are, in the process of doing right now. We have a couple of validators run by other companies, the big ones, not front-running our marketing here, but we definitely see the need for it. But I believe that, this is kind of the trade-off that you can make, just because the probability of the regulator coming in and killing your company is fairly small, and the outcome would be basically the same as if you were to misprice or as if you were to go offline as an oracle, right? Which can be most of the time solved by being fairly concentrated, right? So the expected value in my mind when it comes to not being properly decentralized in terms of the validator network is, is way more negative when it comes to the higher probability events like mispricing or going offline than it is when it comes to being cut off by a regulator, because the probability of that happening is fairly small. So that was kind of the thinking, at least in my mind, when I sort of recall it in terms of, okay, there is certain avenues where we have to make some trade-offs at the beginning to get the product out on the market, and then we can progressively make sure that it's co-share on all the possible verticals. This is also kind of, I believe, how Anatoly from Solana builds, products. He basically says, this is kind of a different example, but just to give you some trade-off benchmark here, he basically says, what we optimize for is security. It's not, the liveness of the blockchain, right? So we make sure that the money is secure. The chain can go down, and we just say it outright that the chain can go down. And if that happens, it's because we build the product in a way which, in which it sometimes breaks. It sometimes breaks. We iterate on those mistakes and make sure this doesn't happen the same way, right? So this is kind of the trade-off that we also had in mind, but on different verticals when it comes to building the product.
Okay, would it be fair to summarize that Chronicle is this OG project, kind of the king of the hill for a longer time? Also more conservative in how they approach things, because also numbers speak for itself. Like Chronicle, I checked, secures 8 billion across 5 protocols, I think. 10? Oh, sorry, maybe I should have used the graph and not some other data provider. And but Redstone secures 1.7 billion across 50 protocols or something like that?
Yeah, that depends on how you count it as well, because DeFi Llama specifically excludes bridges from it. So with bridges, by bridges I mean things like, for example, Puffer. So they use us for internal logic, which is not like a bridge. It's an LST protocol, but they use us to secure the TVL that is there, which is a couple of billion. Solve, Lombard, and a couple others. It's closer to like 5, 6. But yeah, that's definitely smaller than Chronicle, because obviously Chronicle has some of the biggest protocols like lending markets using them, which is easily portrayed by DeFi Llama specifically with the methodology that they've got.
Okay. So that's interesting. So we have these two players, they do different trade-offs, and I think that makes actually a market, right? Like whatever as an Oracle consumer you prefer or are your needs, then you would choose one of those. Then I want to give a quick opportunity for each of you to kind of highlight recent developments. I think, Nick, you talked quickly about the verified assets before, but like I didn't really understand, so maybe you can explain me and the audience again.
Sure. So I think over the past 12 to 24 months, we've seen kind of an explosion of adoption of tokenized assets, or as some people call them, RWAs. Terrible name. Stop calling them RWAs. Finance people look at us like we're really weird. They're tokenized assets. Okay, but that's really going to help DeFi kind of scale. Right? Because right now DeFi is kind of limited by what is the value of all of the crypto collateral in existence, and if BTC and ETH and Solana are not pumping, then DeFi doesn't really grow, right? But there's tens of trillions of traditional assets out there, right? And so it's really this onboarding of traditional financial assets into crypto that's going to be kind of the catalyst for DeFi kind of taking the next level up. And so what we launched in August was this tokenization oracle that we call Verified Asset. We launched it in partnership with M0, which is a stablecoin protocol backed by treasury bills. And since then, we've, in the last couple of months, we've onboarded Midas, we've onboarded Centrifuge, we've onboarded Superstate, and a couple of the other largest asset issuers in the space that we haven't announced yet. And so it's I think it's a really exciting new product vertical, and I think strategically we're really well positioned to execute on that.
On our side, I would say still most of the things that we do are purely on-chain, specifically when it comes to yield-bearing collateral for lending markets. So we used to be super deep in ETH LSTs when that was the name of the game when it comes to the collateral that people would like to see at lending markets. Then it was LRTs, then different types of stables as well, or tokenized hedge funds like Ethena, for example, but still staying within the on-chain context. Now, Bitcoin, I would say, is the name of the game when it comes to bringing it to DeFi and raising the liquidity bar, and just bringing some net new users over from the Bitcoin ecosystem, which usually are very, very wealthy, right? Especially the miner circles. So I believe we are doubling down on that as well with the AVS part that we are building. So also using restaking for a couple of things internally, for example, making the token productive, or further decentralizing certain pieces of our backend, and then being very much plugged in within the LRT/Bitcoin LST space of actually actively participating as an AVS as well in those ecosystems. So I would say this is the main focus coming into 2025. Now, with the new regulatory changes that I believe, all can expect in 2025, there's definitely going to be more and more focus being put in the I guess tokenized assets aspect, just because I think it's a very fair point that this just raises the bar for what can be done. If you want to build a stablecoin product that's entirely based on chain collateral, you can only get so far, and at some point you need to have something from the outside because the liquidity here is just not enough for it to grow. Right? So the same situation applies to DeFi. If you want really, really deep liquid markets that are not going to be so volatile as they are right now, you just need the injection of capital from the outside, which is in the form of tokenized assets. So there's definitely going to be more and more convos like this. But yeah, let's see what happens after, I believe, the 20th of January, right? When the guy needs to be, I guess, officially comes into the power, and and then we will see. But definitely looking into that market as well, we understand that this is probably going to be the next steps for how DeFi grows.
Do we have time for audience questions? So, any questions from the audience? No? I mean, I have more questions. But I think we're at the end of the panel. Thank you so much for coming, and I hope you learned something. I learned that we don't talk about real-world assets anymore. It's called tokenized assets. Thank you so much.
All right, let's try again. Oh, this one works. All right, guys. Well, thank you, gentlemen, for a fantastic panel. And thank you, Simon, for always bringing the best pants to Web3. Our next talk comes from Lisa Axelrod, who joins us from Aztec. Aztec is a privacy-first L2 on Ethereum that utilizes client-side proof aggregation. Lisa is going to show us how client-side data management is revolutionizing on-chain privacy. So let's put our hands together for Lisa as she takes the stage.
Nice. Hello, everyone. Very nice to be here. Today, I'm going to speak about on-chain privacy and client-side data management. Let's start. From ancient times, people were concerned about on-chain privacy. On this picture, you can see people are trying to hunt privacy. It's not easy. It's not easy because it's not like when we ask, like, what is on-chain privacy? To hunt, to catch something, we need to understand what we are catching. And on-chain privacy is a bit vague definition. So let's think, which creature are we going to hunt? Not any privacy. At least we want privacy on Ethereum. Why? Because Ethereum is, first of all, because we love Ethereum, but not only this, because it is a robust layer, and it makes a lot of sense to build our privacy layer on top of a robust layer. So we want our privacy layer to be on top of Ethereum, meaning we want our privacy layer to be on top of fully transparent layer. That's already quite tricky. But OK, if we stick to this construction, will still any privacy work for us? Like, let's think. We have some monolithic, isolated private layer, and some stuff is happening inside. And are we happy with that? Not really. Because what we want our privacy layer to communicate with the rest of Ethereum world. We want our privacy layer to communicate with Ethereum layer, with other layers, with other applications, because we don't want to be a lonely guy sitting in the corner alone. We want to be a cool guy integrated in the ecosystem. But even that is not enough. If we want to communicate with other creatures in the Ethereum world, for example, we want to communicate with Uniswap protocol, we need to be able to make some things public and some things private. Because, for example, for Uniswap, it should be able to update the state of liquidity pools, meaning that we can have the case when we have private users' identity, but we still have to make public the amount of token and what was swapped. Otherwise, we are the lonely guy sitting in the corner alone. So this is our creature, and we are here to catch it, even though it's not easy. How could it look like? I don't know, but maybe like that. Or like that. Or like that. Something not very simple, pretty fancy, pretty cool, a bit tricky. So how to hunt the privacy creature? I will give you the full list, and then we go one by one and take a look at each of them. So we discussed already, we want to be on Ethereum, because we love Ethereum, and because Ethereum is a robust layer. We also want to have public and private state, because we want to communicate with the rest of Ethereum world. And we also want to have public and private functions in smart contracts, so that we can make choice what is public, what is private. And we want to utilize client-side proof generation for it. And we want this proof to be zero knowledge. This is extremely important. So we start with this state. Public and private state. For public state, it's pretty straightforward. Public state means available for everybody. It's like on Ethereum. It utilizes account-based model. And what it means is that this is the database with some keys and values. So in this example, keys are accounts, Alice, Bob, Charlie. Values are their balances. When there is a transaction, the balances are updated. So Alice sends Bob 10, Alice's balance is updated, and Bob's balance is updated. That's it. Can we use account-based model for privacy? Let's think. If we just encrypt everything and now perform transactions on like that? Not really. Because if we execute a transaction on encrypted entries, people still can see which entries were modified. And by retrospectively analyzing accounts activity, a lot of information can be retrieved. And it means we already don't have any privacy. That's it. So for privacy reason, our friend is UTXO model. In UTXO model, account states cannot be modified. Instead, the model operates in the append-only manner. Meaning that, we can just add, only add, nothing else. And when we want to update an account state with UTXO model, we need to destroy some existing nodes and create some new nodes. Who are nodes? Just entries in the table we've seen several slides ago. Table, this is node. That's it. So let's see the same example, but now with the UTXO model. Alice sends Bob 10. What we do? We cross out Alice's previous balance. We create a node with new Alice's balance. And we create a node for Bob with his 10 balance that reflects the transaction. And now we can encrypt all the entries, make our updates without causing any privacy leak. That's what we wanted, because in this thing, the first and the fourth belong to Alice, but we have no idea from this. But now it's a bit tricky, because I first said append-only mode, where you can only add, but then I said, OK, now you need to cross out. So let's learn a bit how append-only mode works. Modifying an entry in the UTXO model means destroying the existing entry and creating a new entry or entries reflecting the transaction. How can the node be destroyed in the append-only mode? With the help of nullifier. A nullifier is a commitment corresponding to a private entry that was destroyed. That might sound a bit cryptic. Throw it away, look at the picture. We have our UTXO model. And by the way, we have trees here. We had tables before, but this is just the way to organize. It's the same database. It doesn't change anything. It just look better. So we have our UTXO tree. In the UTXO tree, we have some entry. We want this entry to be destroyed. What we do, we create a nullifier in a separate nullifier tree that corresponds to this entry. If there is a nullifier for the entry, it was destroyed. If the entry does not have a nullifier, it is still valid, it still exists. That's it. The trick is that only the node owner is aware of the correspondence between nodes and nullifiers. So if it is node of Alice, it's only Alice who knows that the nullifier exists for this node. The rest of the world has no idea. So a bit different example. Alice has 100. So we have a node where Alice has 100. And she's sending Bob 10. So she destroys your 100 node, meaning that she creates a nullifier for this particular node. And she also creates a node for Bob with 10, and a node for herself reflecting her updated balance of 19. So you see, Alice had a node. She creates a nullifier in the separate nullifier tree, meaning that this node doesn't exist anymore. Instead of this, there is a new node with 90 for Alice and with 10 for Bob. Bob then can decrypt the node, get access to his 10, and he's happy. So I hope I convinced you that for public state, it makes sense to use a count-based model. For private state, it makes sense to use UTXO model. And we got some intuition how they work, and what is more important, why we made this choice. So now we have smart contracts on AdStack that consist of public and private functions and also public and private inputs. And developers can choose what to make private and what to leave public. Why do we want it? Because we want private DEXs, or we want private lending, something that requires some external party to be aware of some piece of information. For example, if we are doing decentralized lending protocol, and we want anyone to be able to join as the liquidator should be aware, for example, of the collateral amount. So he knows, like, if there is any need to liquidate anything. So the smart contracts on AdStack are composed of private and public functions, and that gives us programmability. So now we have this fancy creature of smart contract we wanted to execute. How it is executed? First, all private functions are executed, then all public functions are executed. Whatever we want to stay private, it should be executed client-side on user's device. What it means client-side? It means either smartphone or laptop browser. The cluster of GPUs, even if I'm user and they are my personal GPUs, do not qualify as user's device. Me and my friend third-party prover do not qualify as user's device for client-side proving. So the proof of correct execution should be generated client-side on user's device. Yeah, this is our friend, client-side proof generation. And yeah, all private functions are executed client-side. A proof of correct execution is generated and supplied to the mempool. And the sequencer verifies the proof and executes public functions and produces a block. So these strawberries guy are client-side proofs. They jump into the mempool. In the mempool, they are verified by the sequencer, who then executes public functions, builds a block. All good. But not as simple. what is the transaction floating in the mempool? These strawberry guys, I mean, what is the anatomy of the transaction? And it looks like that. We have client-side zero-knowledge proof, and we also have effects from private execution, emitted node hashes, encrypted nodes, nullifiers, as well as requests for executing public functions. And there are many of them floating in the mempool. And the last but not the least, client-side proof should be ZK, meaning zero knowledge. Zero knowledge proof, zero knowledge snark. No, a regular snark does not qualify. Even if it is your favorite, the best in the world snark, but it's not zero knowledge, it doesn't work. Why? Because it leaks privacy. What is the wide definition of zero knowledge? It says that when the proof is verified by the verifier can't retrieve any additional information except for that contained in the proof. And in our case, the verifier is the sequencer, and it is very important for us that the sequencer, while verifying client-side proof, cannot retrieve any information about what has happened client-side. So let's wrap it up. We wanted programmable, composable privacy on Ethereum. We got it. For composability, we have private and public states. For programmability, we have smart contracts consisting of private and public functions and inputs. Private functions are executed client-side, public functions are executed rollup side, and client-side proof should be ZK. Why does it matter? I mean, why does it make sense to make such a huge job of constructing all these new things? Otherwise, why does privacy matter? Whenever we want to build serious stuff, we need privacy. I mean, like DeFi, privacy. Identity, privacy. Products for emerging markets when people and governments are not really friends, privacy. Products for B2B and enterprise, privacy. Products for governments, privacy. A product where everything is public for everyone in the world just doesn't fit the reality. Of course, there are some cases when we don't need privacy. For example, if we are playing around in fun mode, only experimenting with tech, maybe that's fine not to have privacy. Sometimes privacy can be harmful. For example, if we are building an aquarium. Imagine we are building an aquarium. We want everyone to be able to see our fish. If we make it private, aquarium doesn't work. But if we're serious about building real products for real users as real companies, and the product is not an aquarium, we need privacy. That's pretty much it. Thank you so much for listening. If you ever have any questions about privacy, zero knowledge, Aztec, whatever you want to talk to me about, I'm very responsive on Telegram and Twitter. Please message me, ask questions, argue with me, whatever. Thank you so much, and if there are any questions.
Hey, so I have a question because from what I understand, the contracts on Aztec are kind of private as well, right? So if you're executing a transaction that has to interact with a specific contract, do you need to know the code base or the bytecode of that contract to be executed? And if you need to do that, how do those bytecodes kind of get distributed to the users that actually need to interact with those specific contracts? And is that leaking privacy in any way as well?
The bytecode privacy is up to the developer. So depending on what someone is building, they can go with the option of bytecode privacy. But I think it's a binary thing. You either make it private or you make it public. You can't make partially.
Does anyone have any more questions? All right, thank you so much, Lisa. Learned a lot about privacy, but also how important it is to fill your presentation with really dank memes. So thank you, Lisa. Our next speaker joins us all the way from Argentina. And it took this gentleman 36 hours to get here. And I wish he brought me an empanada, but I'll still let him come up on stage. Pablo from Edge&Node, please come on stage, joining us today to talk about the importance of designing decentralized data protocols. Let's go. Put your hands together for Pablo.
Go. Can I do this? Yes, okay. Hi, folks. It's good to be here. So, as Brian said, thanks, Brian. My name is Pablo. I'm in the research and protocol team at Edge&Node. This is one of the core dev teams in the graph, and we work in the protocol, as the name of the team says, that makes the graph work. So the graph is a lot of things, but among other things, it is a protocol for data. You might know the graph from subgraphs or substreams. The underlying mechanisms that make these things work, they were designed as part of the original protocol specifically for subgraphs. But a lot of the work that we've been doing has to do with generalizing that and also modularizing that so that they can be used for other things related to data in general. So there are some learnings and some kind of fundamental aspects of these things that I'm going to go through. If you're familiar with the graph or similar protocols, some of this might already be familiar, but maybe it shows a different way of looking at it. So I'll start with what is a data protocol. It's something that allows a consumer to get some data. So very simple, right? There is someone that wants data. They go to the protocol. There are some data sets there, and they somehow get the data they want. Not a lot of complexity here, and this is not yet like everything that makes up the protocol, but we're getting there. You need someone on the other side that is actually going to serve you that data. They are going to process that data set in some way, maybe materialize it, and then they're going to give it to you through the protocol, right? So this is getting closer, still not a decentralized protocol. We add another provider, and then we're done. Thanks for coming to my TED Talk. Well, yes, there are a few things that we need to actually make this work, right? This is a decentralized protocol. The consumer wants the data. They query it. There are many providers behind the scenes. And you notice I omitted the dataset registry from there. It's still behind the scenes, but I'm going to focus more on the relationship between the providers and the consumer throughout the whole thing. So first, why do this, right? Why would you want to build a decentralized protocol for data? What are the benefits in that? There are a few. The most obvious one is redundancy and availability. You have many providers that are there ready to give you the data. If one of them is down, you can query the other one. A super important one. And to clarify, I'm talking about architectural and political decentralization. That means many machines, but that are run by many different people or entities. The other key aspect is censorship resistance. And a question to ask yourself there is, how many people do I need to bribe or coerce to bring down your application or whatever you're using to consume that data? And an important aspect then is also avoiding vendor lock-in. If you've read Read, Write, Own, there's this idea of attract-extract cycles. You can have a very amazing centralized network, and you are attracted to it because it's useful to you, and then once everyone is using it, they can start extracting value. A decentralized protocol helps you avoid a lot of that. I added price with a question mark because it depends exactly on how you build the protocol, but there is the argument that having a lot of providers competing amongst each other will give you better quality for the same price, or or a cheaper price for kind of similar quality, because you have this competition and because the providers aren't actually competing on marketing, they're actually just competing on quality of service. And then finally, but this is super important, maybe a superpower of a decentralized protocol in the Web3 blockchain world, is you can have token-based incentives, for instance, for dataset creation or curation, and also to bootstrap this provider this provider network of the people that are actually serving the data. This comes at a cost. There are a lot of challenges in actually making this work. You have anonymous providers or pseudonymous, and you want the data to be good data. But at the same time, there may be malicious actors that can profit from giving someone bad data. If, I don't know, an application has a token, you flood that application with bad data, and you short that token, you could make a good deal of money doing that. So the typical way to try to avoid that is you go to someone who is reputable for that data. You go to someone you trust. But these are centralizing forces. These are barriers to entry for people who want to join as providers to a network. So you want to design a protocol in a way that, like, if you need those, OK, let's have them. But try to minimize how much you rely on those. So to approach these challenges, we're going to look at 3 types of data interactions. Request-response, like in a subgraph, I'm querying something, get a response. Streaming, like substreams, where you send a query and then you pipe data constantly. And then there's recurring work, like actually running the indexing to prepare a subgraph for indexing, or actually this applies to any extract, transform, load pipeline for data. And there's 2 dimensions to consider that are provider abstraction, like how fungible are providers, and consumer abstraction, or permissionless access, how fungible are consumers for the provider. And Graph Horizon, that is a big upgrade to the graph that we've been working on, kind of approaches these challenges in a modular way so that arbitrary data protocols can be built on top of the graph. So if you're thinking of building a data protocol, you could consider using these that already kind of apply the principles that I'm going to describe today. So the first one, provider abstraction. A typical way to think of a protocol is as a marketplace. A consumer comes in, they want data, they choose who they want to interact with. That usually relies on the reputation. I'm choosing someone who I think is a good provider or has a good history or whatever. But you want to build a protocol, I would hope, in a way that abstracts the provider a bit more so that the consumer doesn't need to choose. Because, again, reputation and trust are centralizing forces. If you can actually abstract the provider away from the consumer, you get the most decentralized possible, you get all of the benefits from decentralization. Obviously, it's very hard, sometimes even impossible, to achieve this full abstraction. This is going to leak. So it's more about like moving across that spectrum as much as we can to the point where the consumer doesn't need to care about the provider behind the scenes. And then the other dimension is usually your consumer will go to the protocol through some form of gateway because they can simplify billing, because they can do the routing. There are a lot of benefits to having a gateway there. But if there is only one gateway that your consumers can use, then all of these benefits that we were discussing are kind of lost. So you want to have a scenario where a consumer can either access the network directly, acting as their own gateway, or they have a variety of gateways to choose from. But this requires some things in the protocol level so for providers to be able to serve any customer. So the first dimension that was provider abstraction is covered mostly through making sure that data is correct, and you have cryptographic security to guarantee that data is correct. So if a provider is giving you bad data, the typical approach is we slash them, and that establishes a cost for doing bad things. You don't want to have this in a way that, OK, it's the consumer that needs to raise a dispute. You generally want to have a high probability of detection so that this is just a deterrent. It's not going to happen in practice that the consumer gets bad data, because everyone knows that if you do it, you're going to get caught. So this is a very necessary thing for us to be able to abstract the provider, because it replaces the trust with that confidence in that deterrent. Obviously, it requires some form of verifiability, like I think Sam described in the morning. There are many ways to approach that, and they have different trust assumptions. You want to move more towards fraud proofs or validity proofs, but you might make do with arbitration or a voting system in the meantime. And these are some of the kind of default dispute mechanisms that we're including or working on as part of Graph Horizon so that protocols can launch very quickly with that. And an important distinction from like blockchain proof of stake systems like Ethereum or something like that is a single bad node can do a lot of damage. You query from a single bad provider, you get bad data, and that might be enough for an attacker to make a profit. Whereas in a blockchain, you might have to kind of bribe a majority of the participants to actually do some effect, some real effect. And that means you probably want to have people stake more the more work they do so that they don't get to a scenario where they do one attack and then they get another one for free because they're going to get slashed the same amount. So Graph Horizon approaches this in this way by allowing providers to split their stake across different data services like subgraphs, substreams, some weird SQL product or whatever, and having like different ways to kind of account for that stake within each data service with this general idea of having a stake to fees ratio or some proportion of how much you have to stake based on how much work you're doing and how much risk you're exposing the network to in a way. And then the second dimension is a provider needs to get paid. They need to know that they're going to get paid. Otherwise, like, you're not going to work for someone without knowing if you're going to get paid. If that someone is anonymous, it's not someone that has a reputation or that you trust from before. So you need to prevent two risks. One is that the provider takes the money and runs if you pay in advance, and the other is that the consumer takes the data and runs if you do the work in advance. So usually there's going to be a gateway abstracting the billing there. The top example is for a request response where the gateway usually is going to do the routing. The bottom example is the gateway just abstracts the billing and then the consumer goes directly to the provider. But the key idea is you want to have a scenario where you pay in advance, but only enough that is not profitable for the provider because they have a cost of setting up business here to just take that money and run. And that is kind of essentially what we've captured in the timeline aggregation protocol that was developed by Semiotic in collaboration with Edge&Node. That has this idea of sending a receipt together with each query, and then the provider, when they're not comfortable with how much outstanding debt there is, they can aggregate those receipts and redeem them on chain. So this abstracts a lot of the like trust. It removes a lot of the need for trust in these kind of request-response interactions, but it also works for streaming. So this is not yet integrating to any streaming kind of data service, but it could be. And the same protocol can be used. You just pay for a certain amount of bytes that are going to be streamed to you in advance. And then one thing that we're working on is taking these same principles of having just enough assurance that you're going to get paid, and we're applying it to general cases of ongoing work like indexing or any sort of ETL pipeline. So the gateway deposits something on an escrow, and then the provider can do the work, and they can post some form of proof or commitment that they've done the work on chain. Whenever they do it, they can collect a payment, and there's no need to send any new voucher, any new payment from the gateway, because that voucher already establishes the rules on chain of how much you can collect based on the amount of work that you do on each period of time. And usually we're thinking like the gateway is going to abstract this, and what is the consumer actually doing there? Nothing. They're just chilling for now. They're going to query the data later. But this gives us the scenario where the consumer could run their own gateway, and they know that the work is going to be done because there's going to be a gateway there that's going to be choosing the providers and paying them in this way. So Graph Horizon has a part of payments that handles all of this with these two generalized collectors from the escrow. One is dapp that helps for request-response cases. The other is this DIPS, direct indexing payments. We need a better name. But it's this idea of, OK, you can send a single voucher and then have recurring collections that are trust minimized. So these are kind of the basic underlying structures that make up the graph. The original protocol has a lot of these principles, and we're kind of modularizing them as part of a Graph Horizon. But there's more to that. Once you have the cryptoeconomic security and you have the trust minimized payments, that gives you the basic things for you to have any data protocol built on top of that. But you probably want to have better incentives there. So on the one hand, you want to have incentives for providers, because getting a base of high-quality providers is hard. That is one of the best things that the graph has. That is this community of more than 150, I think, indexers that are very technical. They're very good at running infrastructure for this kind of data pipelines. And things like indexing, this kind of ongoing work, may need to be done without having a clear idea of how much query demand you're going to have for that, like later in time. So token issuance is a great way to bootstrap this. This is what indexing rewards do in the graph today. And there is a lot of ongoing work, a lot of ongoing research on how can we generalize that and improve that and make it more efficient and more useful for other kinds of incentives and for other kinds of data services like this. Obviously, it's not free. Issuance has a cost to everyone in the protocol. But if that issuance allows you to get this high-quality base of providers, there's a lot of value in that you get back from it. And then another step is, another thing to consider is, the data is usually interconnected. You can have ETL pipelines that are composable. There's a lot of ongoing work in building data pipelines that are composable. But building them and building like a particular subgraph, for instance, that can be valuable, or a substreams or something like that, organizing them, figuring out which ones are valuable, that's a lot of value added to a network. And there are two ways to incentivize that. One is issuance. In the same way as with indexing rewards, you could have issuance to incentivize other kinds of value creation. And another one is having fee cuts or something like royalties, where people consuming data are paying a small percentage of that query fee to the person who created that data set, or even an upstream data set that that data set depends on. So you could have like incentives for people to build data on top of existing data, and that way you could create a lot of value in useful information that people can come and consume from your protocol. And the diagram here shows something that is in the works. There's a proposal coming up, but the idea of being able to distribute fee cuts to a sponsor that pays for that initial indexing, and then that way you can like identify valuable data sets, you pay for the indexing, and then you get a reward when other people query it. And I think Rem might be in the audience who's actually working on that proposal. So these are kind of the general things. I saved my corniest meme for the end, but the idea is each of these things by itself doesn't give you the full thing that you need for a data protocol. When you combine them, you get this very powerful machine that allows you to serve arbitrary kinds of data in a lot of different ways to consumers with probably very high quality of service, because you have this decentralized base of providers behind it. So yeah, that's it. Thank you. I think we have a few minutes for questions, if there's any.
What do you think is a fair fee per query to pay? And are there any existing models where consumers are actually already paying the fees yet?
So do you mean the fee for a consumer to pay in general for each query, or?
Yeah, because like the most use cases of the graph that I know so far are free. Like it's based on like free querying. No one is paying actually for data, and so I'm wondering if there is anyone who's paying, and like what is a fair fee to pay for consumption of data?
So there are actually a lot of people paying for queries today. Right now, I think the current price when using the graph is around $40 for 1 million queries. The price can actually be dynamic and determined by the indexers and can like fluctuate in the future. But what the fair amount is probably depends on like how much people are willing to pay and how much people need to be paid for it. Like, yeah, the protocol is designed so that you can have a like supply and demand mechanism, and like the indexers themselves are the ones setting the prices. The gateway can have a budget and like be sure they're not paying more than that, but you can have dynamic like competition and dynamic pricing. So I don't know if I have a concrete answer to that. Hopefully that's kind of, yeah. But it is worth noting that there are people querying and paying for queries on the graph today.
Thank you.
Sure.
Hi, thank you for the presentation. I worked with the graph for a while, and I know that usually when you support a new chain, it is related to indexing the data on chain and getting this available for the consumers. So you kind of pay for a query, you get the data. But is there any supposed solution if the consumer is on chain? So it's a smart contract on chain, which is getting the data. Is it supposed to be via oracles, or there should be a solution from the graph?
That's a great question. So I think Cambrian, that is what Sam presented in the morning, would have some of that, where you can have data processed by the graph network that is then posted back on chain, and you need like very strong verifiability guarantees for that. So there's certainly that is in the works. And then, but in general, kind of the payment mechanism that I described for indexing can also be used for anything that you're posting the data on chain, because you can collect payment at that time. So I wouldn't say there's something that exists right now that does that, but there's certainly kind of the base of the protocol does allow for that.
Got it. Thanks.
Sure. I think we're almost at time, so that's going to be all. All right, thank you all.
All right, thank you, Pablo, and thank you for putting some also like really dank memes on that presentation. We love data and memes over here at Datapalooza. Cool. All right, so I want to introduce the next speaker. We have Mr. Toby Schreier from Grow the Pi. Grow the Pi is an Ethereum Layer 2 analytics platform that is public goods funded. Toby's talk is titled Economics of something. Economics of Ethereum Layer 2s and their DA solutions. So please join me in giving a warm welcome to Toby.
Continue. Okay, there we go. Let's see. Perfect. Cool. Thank you. Hello. Can everyone hear me? Yes. Perfect. Hi, yeah, I'm Tobias. Thanks, Brian, for the introduction. So yeah, I'm one of the co-founders of growthepi.xyz. I'm going to go into details later on about the platform. So yeah, my title is, of this talk is Economics of Ethereum Layer 2s and their Data Availability Solutions, because there's a huge, like discussion around, okay, are all these Layer 2s, Layer 3s actually viable? Why do we need them? And then all of these data availability blockchains that we have now as well. So do they not take away like fees and actually revenue from Ethereum itself, right? So is Ethereum itself actually then sustainable in the long run? And this talk is not going to be very technical, I think. It's going to be more from the, let's say, the design side and the economic side. So I hope that's all right with all of you. And I'm going to give a little intro about myself, about Grow the Pi and the data, and have some examples. And actually one example that I'm going to go through, and later on we're actually having a look at live data as well. So yeah, quick background. I'm the design co-founder basically of Grow the Pi, because for us it's very important that we actually have a good accessibility to the data that we provide. And yeah, exactly, the rest is actually not that important. And growthepi.xyz, if you don't know it, is a data analytics platform that we established in February 2023. And it's Ethereum Foundation funded. Like, we've got a couple of optimism grants after that, and kind of really have this platform as a public good. So everything's free to use, of course, the platform itself, but also the data you can get through our API and have your own, make your own analysis and whatever you want to do with it, actually. Going to have a little example about that later on as well. And what you can actually see on GrowThePie is we started as purely layer 2 focused, but now since the whole narrative is also changing, right, because layer 2s and layer 3s are also Ethereum, right? That's the whole purpose of this whole roadmap of Ethereum. And so we're going to have much more Ethereum data in the near future as well. And then right now we're tracking at least 24 layer 2s. So what you can do on GrowThePie is that you can have fundamental metrics like activity metrics, but then we also have economics metrics, and we do a lot of smart contract labeling. So that allows us to actually categorize the usage of different layer 2s, and people can actually see, okay, why would I be on a different layer 2 at any one time, and what's running on these different layer 2s. And we have more data availability metrics, etc. And why actually this talk? So I kind of already touched upon this. Like we have now, if you also go to L2Beat, if you're familiar with that, like we have more than 100 active scaling solution projects, right? I mean, we have bigger ones, of course. I got a screenshot from our landing page. Of course, the biggest one, obviously, right now by far is Base, then followed by Arbitrum 1 and OP Mainnet. So these are the bigger stacks, right? But then, of course, we have like some others coming up that are also like building more and more and kind of differentiating also through the tech, but also the accessibility through the usage. And of course, like now, when we look at that, everyone said so we are now at DEF CON in Bangkok, right, 2 years later after Bogota. And these were like my main takeaways 2 years ago. So Ethereum needs to scale, okay, we're getting there. Ethereum needs to be cheap, also got there. We're going to look at that later on. And Ethereum needs better UX. But now if you actually think about that, so if we go one back, all of these different layer 2s, okay, like where's our better UX, right? That's a different topic to solve, but we're talking more about the economics and why actually does it actually make sense to have these different layer 2s. So going into different like industry or drawing a comparison would probably be like 3 different main industries that we all benefit from, right? So we benefit from cloud computing, from telecommunications, and transportation when you think about it. So cloud computing, like probably most of us that are, you know, like software engineers, builders, and so on, we are using probably AWS or Google Cloud or any other service like this. And of course, they charge for computation, they charge for storage, and Ethereum charges for transactions, right? And until a couple of months ago, that was actually pretty expensive. Telecommunications providers, like what the metrics are that we typically look at there is like the bandwidth, right, and the latency. So we want to, you know, if we want to send a message anywhere in the world, we actually want it to go through straight away, want a high bandwidth, especially think about when a lot of people are in one place. We usually have that problem with a couple of telecommunications providers that there's actually nothing going through anymore, right? So this is also a metric that we can look at around blockchains as well. And then, of course, obviously, also transportation. Right? Transportation, when you think about it, especially also like here or in Latin America, we have like a lot of cars, a lot of vehicles, right, in one highway. And of course, we're building more and more highways to actually kind of tackle the congestion that we actually have. And that's the same thing that we do with different scaling solutions, right? So we have a couple of optimistic scaling solutions, so basically where everything's pretty fast, because an optimistic scaling solution would say, look, we are actually trusting the transaction, that it's actually valid, and only if fraud is suspected, that would then be reversed for like 7 days. There's a couple of, so you have some time there. And then CK rollups, they actually take this whole computation about fraud detection off-chain, so they have a lot of high computation off-chain. That's going to be relevant later on when we look at actually some metrics. And then we have a couple of other, obviously, like scaling solution technologies like state channels, plasmas, and so on. So they are all for different purposes, right? And so what are we going to look at actually, and how does data actually help us to decide, especially as a builder, to actually see, look, what should I be using, on which, let's say, layer 2, layer 3, should I maybe have my decentralized app on, or even if I'm building my own L2, L3, right? So what would I actually, like how can I analyze data to actually say, okay, that is the right solution for me, because we have different stacks, right? We have Arbitrum Orbit, which is then optimistic based. We have the CK Sync Elastic Chain, which is obviously zero knowledge based. And so you can actually see through data, okay, how do you actually decide on the right tech for you? And we are going to look at this in a practical example as well, but just that you already know, like the transaction throughput, so which is a crucial metric, right, for actually analyzing, okay, how much capacity does this scaling solution actually have at any one time, right? Imagine there's a lot of people coming now and want to do one thing at the same time, and this the scaling solution doesn't actually have the capacity. I mean, there's a lot of criticism around that at the moment, where other blockchains, especially layer ones, are actually more efficient, right, because they have more throughput. And then we also look at the fees paid by the users, or the revenue for the chains, because a chain needs to be viable, right? We had this example with the public goods network, for example, by Gitcoin. This was not a viable solution because they wanted actually to share a lot of the fees that were generated by transactions with, let's say, public goods projects that are launching on the chain or somewhere else, right? And this whole solution wasn't viable because the costs were just too high. And then we, of course, we have the settlement and DA costs. So normal ones would be, let's say, we have different solutions that say, okay, I'm actually using Ethereum for my data availability as well, so for my data storage, using call data, using blobs, and then we have other alternatives that is, for example, Celestia as a like focused data availability provider. And then we have, of course, like security centralization costs. That is, for example, when we talk about based rollups, so it has nothing to do with base, but let's say that use a decentralized sequencer that is actually using Ethereum mainnet as a sequencer, right, which is a bit more expensive, but we're going to have a look at that as well. And I talked about, like, I have a few examples what we can actually look at. So I talked about the throughput, right? And for example, when you now, let's start with Ethereum itself. So we have Ethereum enabled, and you see this flat line here, the gray line, which is Ethereum. And there you see Ethereum is always at capacity, right? So that's why the fees are so high on Ethereum mainnet, right? Because after that, of course, you have to pay a premium to actually transact on that, to actually, like, that your transaction goes through. But we already saw that with a couple of other layer 2s as well. So I have like 5 enabled here, or 6 enabled. And then you see here this blue line. I mean, that is base. And you see these steps, like a staircase going up, up, up. Because base has the goal to actually go to 1 giga gas per second, so to have a lot of throughput, right? So to enable cheap transactions for a long time. For their users, and that's why they're upping their throughput all the time, so upgrading the tech, but they have to be careful with that as well, so that actually, like, they have enough uptime, right? But as you see right now, they're also, again, at capacity, so they upgraded that in October, and again, like, there's enough transactions to actually fill the whole capacity of the whole chain, right? And then you see some others, like Arbitrum here, that's actually never at capacity right now, and Optimism, OP Mainnet, also upgraded their throughput right now, which then again shows you, look, if you're a builder, for example, okay, like, does this chain where I'm building on actually have enough capacity for my type of app? For example, if you're building a game, right, we all know, like, if you play a game, you have a lot of maybe tiny microtransactions, so let's say OP Mainnet might not be the most suitable for that, for example. And then, of course, we always talk about viability as well. And after EIP 4844, where Ethereum introduced blobs to kind of be more efficient with data storage, we had this whole fall in fees, right? I mean, for us as users, very good, right? Because of course we don't want to pay, I don't know, $1 to, or like, I don't know, hundreds of dollars on Ethereum mainnet. We want to have these low fees, so that happened in March, right? So after that, you saw like all these chains slowly upgraded to using blobs. Not all of them. So for example, Polygon CK EVM. So I'm not talking about Polygon the sidechain, because that's what we not consider a layer 2, because it's not actually settling on Ethereum mainnet, right? But Polygon CK EVM actually still uses only call data. They haven't upgraded to blobs, but are still managing to actually be quite cheap. And basically, so what does that mean? Do you then have not enough profit, right? Or like, do you not generate any revenue anymore, right? When you have all these cheap fees. But actually, when we look at it, Base right now, so in just yesterday, that screenshot, or like last 30 days actually, that screenshot was taken today, they made $4.31 million in profit, right, in the last 30 days. Just profit. It's not revenue, it's profit. On-chain profit, I must say. And so it's still clear they are very viable. Also here you see at the peak, probably here in March, where they had a lot of transactions. So after blobs were introduced, they now started moving more and more users to the actual chain. And now you see they had, in that month, more than $15 million in profit, right? And well, then there's June 20th, right? And so then we have a couple of winners and losers, because here when we look at the revenue, that is actually quite interesting, because the revenue was pretty high for Arbitrum 1. Because there was I think it was a layer 0 airdrop or some other huge airdrop, and they had to kind of claim that through Arbitrum 1 actually. So Arbitrum 1 on this day made 500,000 in revenue, right, from transaction fees. So you see, even with low fees, it's actually possible to still generate a lot of revenue. Because I think when we talk about, and that's why we are actually, I mean, a side note called kind of grow the pie, because I mean, it might be a bit naive right now, but we say, look, if we actually have enough users, it's possible to not have a zero-sum game, right, but have a positive-sum game, where like there's an actual need for all these different layer 2s, because you're going to split up your target groups anyways, right? So like, remember that? So Arbitrum 1 has a lot of revenue on this day, and Base and Linear, so focus only on these three. And but when we look at this now, so we're talking about the on-chain profit, so that is excluding the rent that you have to pay then to L1 and other costs, like just on-chain cost. So on this day, Arbitrum actually made a lot of profit, right? Like 3 million in profit. And then we see Blast, we see OP mainnet, and we see Base, and Base actually lost money on this day. So that's a huge question, right? Because why do they lose money? And when you actually see that, it's also the same day, and the cost of Ethereum blobs. So we have a logarithmic scale here. They were actually like pretty low, like on blobs, because like blobs are almost costing nothing most of the time until now. But then on this day, because of the high transactions and on Arbitrum 1, so Arbitrum basically kind of was really efficient with all these blobs, and but also the builders actually didn't kind of use these blobs or take away the blobs, right, to kind of make place for new ones, and so that's why the Ethereum blobs costs increased to more than $127,000, right? And Celestia at the same time, so if you used, let's say, the data availability layer, was pretty flat, right? So that's obviously because most of the layer 2s are using Ethereum blobs and not alternative data availability solutions. But as you see, and that is also another thing that you might want to consider as a builder, what you can read from the data, let's say, that Celestia is pretty flat, so it's more predictable actually, right? So because you don't want as a builder that all of a sudden you actually make a loss because of high blob fees, and if the tech is like not as efficient as you wanted it to be, then you actually make a loss, right? We can look at this from a different angle as well, and that's again the same day. And looking at base compared to linear here, for example. So you saw these huge spikes, and also the red one, this spike, is again the cost that base had in this moment. So the cost switch is too high because blobs were very, very expensive in this moment, right? And they were not cleared quickly enough. And so basically in the moment when the user actually transacted on base, they still charged the cheap fees from their users, but once it was actually then settled on L1, the L1 fees were already much, much higher, so that's why actually the loss occurred for base. But compared to that, linear actually had nothing, right? You see a very flat line here, because linear apparently has an ability to predict when the L1 cost will be high, so they're actually waiting a bit to actually settle on L1, and that allows them to actually still stay profitable and not operate at a loss in such moments where we have like a very high demand on the chains, for example. And so basically, again, same day, another metric, looking at it from a user's paid perspective. So imagine you're a user now on these layer 2s, and we actually, like, you think like, yeah, it always costs like 1 cent, right? But all of a sudden, then, I mean, 86 cents is still good if you, I don't know, getting a good airdrop, for example, but still you don't expect like to pay maybe around $1 for a transaction, right? But that happened on Arbitrum 1, and that's why they actually had a lot of revenue in this moment in time. So basically, a little summary to that. So we need to kind of look at different metrics and allow also very, very different people to look at these metrics, especially also builders, and that's why we are building the platform the way we do, to say, look, most of the people are actually not data experts, right? And they might not actually have the money to hire data scientists, etc. But we want to make this accessible. So basically, the different metrics like throughput, revenue, on-chain, profit, that gives also a builder, let's say, an insight into the different scaling solutions that we have. And of course, the tech, you have to know a bit about the tech. For example, when you then talk about Tycho, we might have like a minute to actually look at that. Then you also need to keep in mind, okay, what's actually happening with my tech that I'm building on. And that's why we have different rollups and chains for different purposes, obviously. That was it so far. Thank you very much. And if there's questions, I'm happy to answer them right now, or I kind of show a couple of other metrics. I think we have a couple of minutes maybe to have a look at the actual, getting thumbs up. But we have one question over here.
Hi, thank you for the presentation. I saw you mentioned Celestia versus Ethereum blobs, and are there any insights on any other DA layers like Veil, EigenDA, or any like new ones?
Yeah, that's a good question. Right now, I mean, we are only tracking Celestia and Ethereum call data or blobs right now. But there's also there's one reason for it as well, and I think I have it open somewhere here without kind of I mean, I don't want to say like one is better than the other, but in production right now, actually, like most of them are using Celestia as a data availability provider, right? So that's why I think you can also see that here on the fees. But still, like the bigger ones are actually using blobs, like Ethereum blobs and Ethereum call data. And there's a couple that actually, then here we have one Mantle with EigenDA. For example, Mantle is pretty big. But I think you see the same pattern there, that actually the cost for the data availability is more predictable right now, because everyone thought like, look, blobs are so cheap on Ethereum, so I don't have to worry about it. And especially you saw it in that moment, what I was talking about the whole time, that, for example, Blast as well, they could have had a cheaper transaction to L1 if they used call data, right? But since they were all by default using blobs, they actually overpaid, sometimes by, there's a good thread actually, by like 10 times or 50 times even in that moment. So, and with Celestia, it's just like, yeah, you have a kind of a predictability that's actually pretty steady, like the cost. Yeah.
Got it. And the second question, you showed the charts for profit for L2s.
Yeah.
And there's actually interesting, the same thing for DAs, because they have some costs, maybe some other types of costs, and some revenue.
Yeah.
Do you have any analysis on that?
We don't have like how profitable Celestia right now is, for example. We don't have that. I mean, we just could, you could see right here, I think. Let's see. No, actually, it's a blob producer, so that's the amount of, so that's actually the ones that are using. Let's see if we can do that. So you see that actually Celestia is actually pretty well used, let's say. And compared to that, we have the Ethereum blobs. So like I say, 1/3 Celestia right now, 2/3 Ethereum blobs. But what you also see, and I think that's just going to increase the more, is actually being used by these different layer 2s. You see that actually Celestia is very, very cheap, right? Overall, there's not that much that, let's say, a layer 2 right now has to pay for Celestia. That's just yesterday, and they made 230 in revenue from the layer 2s that are right now using Celestia, right? So there's a lot of capacity right now in Celestia, but so that there's a lot more room to grow, actually, yeah. Question. Any other questions? Yep, one over there.
I'm kind of curious. Thanks a lot for the presentation. I'm kind of curious, what is your stack for powering all the visualization and?
Right now we use hypercharts here as well a lot, do you mean for creating the platform, or?
I mean, how are you getting all the data?
Okay, so we get the data from RPCs. We kind of aggregate the data, and then we have the metrics. And you, by the way, if you want to use the data, also you can just go to our API here, and get it free of charge, basically. All the data that you see on the front end, you get it through JSONs then as well. So it's pretty simple actually to use the data for your own analysis, for example.
Oh, thank you.
Welcome. All right. Yeah. Cool. Then thank you very much.
All right, thank you, Toby, for going so in depth and showing us the power of Web3 data analytics. We have a little extra time here, so what I'm going to suggest all y'all to do is stretch a little bit, but also right outside this door, there is some amazing swag. So this is what we'll do. 15 minutes, get up, stretch, check out the swag, maybe get some water, hydrate yourself. We have been sitting here slowly evaporating, so do that, and please come back in 15 minutes. So at the 55-minute mark, right now it's 3:38, 3:55, please come back for our last panel. It's going to be pretty epic. So see you soon.
Hello, hello. Oh, should I go over there? Oh, I see. Sorry. Welcome. Thank you guys all for sticking around. Really excited about this panel because we have a lot of different perspectives on the interoperable world that is Web3. And more specifically, obviously, multi-chain, which includes L1s, L2s, L3s even. So wanted to kick it off maybe with you guys introducing yourselves and sharing what you guys do at your companies.
Hey all. So I'm Skeletor, or Skelly for short. I'm the co-founder and lead architect at Wonderland. We are a core development group. We work with different kind of protocols in the ecosystem. We try to build cool things. Our URL is DeFi sucks. Should be crypto sucks right now. It kind of got outdated. We don't do DeFi, solely DeFi anymore. And yeah, I mean, we know it sucks. We know like nobody can build everything, so we're just trying to get shit built as best as we can.
Cool. Thank you. My name's Harry. I lead the developer relations team at Chainlink Labs, and what we build is we work on a platform called Chainlink, which is basically a collection of services for developers to do a bunch of stuff that you can't do on a blockchain natively, such as obtain data from the off-chain world, cross-chain communications, automating smart contract calls, randomness, and things like that.
Hey everyone, I'm Mats. I'm a co-founder and CTO at Dune. At Dune, we think of ourselves as crypto's data platform. You've probably seen dashboards or graphs flying around Twitter or Warpcast or something like that. And yeah, we think of ourselves as making crypto data accessible, and yeah.
Awesome. Getting right into it, I know most of us have been here for a while, many years, and there have been a lot of assumptions that we've made along the way around multi-chain ecosystem. Will it be multi-chain? Is it Ethereum alone? So would love to hear some of the assumptions you guys had, which have proven to be true and which you've realized are false or maybe have changed over the years.
Yeah, I can try. So I think the weirdest thing of kind of all of this scalability problem that we're trying to solve is that I thought there were going to be more, let's say, L2, L3, L4, et cetera, et cetera. I think the complexity in the UX that we are seeing right now with just L1s and L2 and like a few other L1s is like too big for us to also include like layer 3s and layer 4s, et cetera. So I think that's the kind of the key thing that I saw that didn't like kind of really made sense of what's my kind of prediction of the future. I hope we get there sometime because obviously scalability kind of goes even higher with those type of kind of layer 3 and 4s. But I mean, whatever, we'll get eventually there.
I can go. I think I probably thought that block space would grow sort of in relation to the amount of apps that we have and activity on chain, and I think maybe block space is growing a little bit faster than the amount of demand for doing transactions on chain, and so I think that's been like the most surprising thing is how quickly, especially this year, we've built layer 2s and layer 3s, and I actually think they kind of work, and the UX isn't actually that horrible. The DevX is worse than the UX. But yeah, I hope we get a lot more apps coming out.
Okay, so my background is I came from the consulting space where I was a solution architect specifically focused on integration. And so when I first saw other chains starting to pop up, other than Ethereum, side chains, et cetera, like I straight away knew that eventually we'd be in a world where chains would communicate with each other, because I just saw them as two or multiple very similar systems that seem like they should be able to interoperate, like connect with each other and talk with each other. So I guess in terms of what ended up being true, just the fact that we would get into the world today where we're definitely in like a cross-chain world where chains can communicate with each other. In terms of things that weren't so true, I would say that I didn't know it would be so complex, I guess. So I always assumed it would be a simple problem that would eventually be solved, just like traditional enterprise applications that talk to each other. But it's a really hard problem to solve, actually, and there's a lot of nuances, a lot of considerations, a lot of security considerations, and I probably underestimated it back a few years ago.
It sounds like all three of you feel you underestimated the complexity, or kind of the multi-dimensional world. There's L1s, L2s, L3s. How do you view your project's role in kind of enabling that multi-chain ecosystem?
Okay, I'll go first. So Chainlink's role, what we see our role in a multi-chain ecosystem is we have a, one of the various developer services we have is called CCIP, Cross-Chain Interoperability Protocol. And that is a protocol that enables the transfer of data or tokens or both between blockchain networks. And we see a future, or our kind of vision for the future is there's going to be lots of chains, hundreds of chains, thousands of chains, public chains, private chains, app chains, etc. And we see CCIP as obviously being the glue that connects them, whether it's a public, private chain, whatever it is. So our role in enabling that future is by creating the most reliable and secure cross-chain communication protocol for developers to use.
Yeah, so at Dune, I think we play two roles. One, as the complexity of understanding user activity once that activity goes across different chains. Like, I think 2 weeks ago, Uniswap launched cross-chain swaps together with Across. And now, actually understanding the user intent is a lot harder than it was 2 weeks prior to that. So I think our role primarily lies in tying together all the pieces when the world actually fragments into 100 or 1,000 chains, being able to offer you that unified picture of adoption or activity. And secondly, more recently, we've also started working on solutions to improve the developer experience. Given that we have all the data from all these applications and chains, we think we can do a pretty good job at like consolidating that into some nice to use endpoints that will be coming out soon.
Nice. So yeah, I mean, the cool thing about Wonderland is that we are kind of this core protocol, core development group for multiple protocols. So right now we have a partnership with Optimism, but we are trying to collaborate as well more kind of on a, I mean, I have a hat that says public goods are good. So I very, very believe, and Wonderland believes, that public goods are the way forward, and collaboration usually helps way more than competition. I mean, competition is good, but ideally, and what we try to kind of promote through Wonderland also with our partners is kind of a spirit of collaboration, a spirit of saying, hey, I mean, how can we build better things together? How can we have this kind of more holistic view of the ecosystem, of the problems that we're trying to tackle? I mean, as Harry was saying, like, there are going to be a shitload of chains very soon. I mean, and there is no clear path or way. Nobody's thinking, everybody's kind of just thinking on their solution and what fits my use case or my specific protocol, etc. There is not, sadly, a lot of kind of intercommunication between teams, especially like core dev teams working on the protocols, which literally don't give a fuck about the business side of things usually. They just want to build cool shit. So yeah, I mean, we are trying to push that kind of boat ahead a little bit.
Harry, I want to come back to you because Chainlink just announced 2 weeks ago, I believe, at Sibos, a really huge partnership between the largest US banks, including Swift and a few other sort of payment infrastructure providers to enable more of like a multi-chain ecosystem. Could you share more about what you guys are doing there? And then also, how could that actually benefit the Ethereum ecosystem, solving some of our other multi-chain problems outside of the banks?
Yeah, sure. That's a big question, and I'll try and give a big answer. So who here, can you put your hand up, was around in the space following it back in like 2019? Okay, we see a few hands here. So back then, banks and capital markets and financial institutions were not really into blockchain technology as a whole, and the technology wasn't really proven. And there were some proof of concepts that were done, but they were kind of just done by like a, you know, future thinking team. Then they'd put out a press release or something. But now banks and financial institutions and capital markets and people like Swift are like really interested in tokenization, and they've kind of realized that the benefits that they can have. And so we're doing a lot of work with some of these people on enabling tokenization for some of their systems. And two things specifically which were a problem back then but aren't a problem now is back then there was no ecosystem of chains connected to each other. Interoperability was not a thing back then. And that was an issue for them because they don't want to go on a IBM Hyperledger chain with their competitors, and they don't want their competitors to see their data and things like that as well. So that was the first problem. The second problem was privacy and compliance. They don't want the Chainlink network or anyone looking at an Explorer to be able to see the transactions that were happening. But now we've kind of progressed a little bit, and Chainlink's done a lot of work, and we've actually solved these problems, and that's kind of why we're doing some work with them. So they don't want to connect to Ethereum, they don't want to connect to Solana, they don't want to bet on a chain. They want to like connect to one thing and have that one thing be the thing that connects them to all of the blockchains, whether public, private, bank chains, etc. So what we've basically enabled is the use of CCRP to be that thing, that glue that connects their systems, or in this case, they run blockchains themselves, usually private blockchains, with other bank private blockchains, or sometimes with public blockchains as well. The second thing that we've enabled with them is we've done some work with ANZ. So for those that don't know, ANZ is probably the biggest bank in Australia, in creating some privacy preserving features for CCRP. So going back to that second thing I talked about, where they can't have you or me looking at the data that they're kind of sending from one bank chain to another bank chain. And another thing is they don't want Chainlink nodes or the Chainlink network or anyone connecting to their private chain and just querying the data and seeing what's in certain blocks or transactions because of compliance laws. So we've enabled basically filtering at the RPC level where the Chainlink network or the Chainlink nodes can connect to their private chain and only do what they're meant to do, only see the data that they're meant to see and only perform the actions that they're meant to perform, but not see or do anything else. So that solves that problem. And then the data visibility problem, we've implemented some encryption where if I'm running a private chain, I can allow CCRP, the public CCRP network, to grab some data or to do a token transfer or something. That information is encrypted, sent using CCRP to the other private bank chain, and then they can decrypt it using basic encryption. And then they can do whatever they have to do on the other side. But then anyone that looks at the transaction data, anyone that looks at CCRP, doesn't see what's happening. So what this enables in terms of the overall ecosystem is it enables the use of the technology to be used by these banking people and capital markets institutions, mostly in a private scenario first because of it's an evolving space and there's still regulatory things that are catching up. But then eventually we see a world where a lot of this stuff will merge with the on-chain public world, the DeFi world, where you have a convergence of the traditional financial world with tokenization and tokenized assets coming on-chain and then making their way throughout the Web3 ecosystem into DeFi applications and things like that.
Cool, that sounds like a really great use case specific approach, and I feel like we kind of lack that at times in the space. I wanted to bring it over to Skelly to discuss something a bit similar, which is obviously Wonderland has been a core dev with Connects, now Everclear, and also Optimism. So you guys are probably quite familiar with the interop problem. I wanted to hear how you guys are thinking about that, specifically in sort of the L2 and Optimism ecosystems.
Yeah, that's a good question. I mean, I'm both kind of bearish and bullish on the topic. There is a lot of work to do. I mean, Matt, you said like you were pretty optimistic. The UX is probably better. At least for me, I know my mom and nobody like in my family will able to use like, I know, say, hey, I want to swap some tokens to this chain, and then I need to have gas also this chain because I didn't have the native token, and maybe it's a custom gas token, so I need to figure out how the fuck do I get the token there to relay my transaction because I didn't pay a relayer fee to get the transaction in. And all of this gets even worse when you start adding like kind of interoperability and making kind of it easier for people to do that. The bullish side of that is that all of that should be abstracted away from the user. Like my mom shouldn't like care about like if she pay like the relayer fee or not. It should be like a relayer that is abstracted away at the application level. I mean, crypto has this problem that we are building a shit ton of infra, not enough products, because obviously it's very hard to build products in crypto. There is no fucking user, so why would you, right? VCs won't fund you. We had a big discussion about this a little bit earlier. So the thing is, that's the problem, right? I mean, eventually we'll get there. Crypto is advancing very, very fast. We know, like, Web3 moves extremely fast. So probably we'll get to a way better point. We are like a very technical team, so obviously we are very good at doing infra. We suck at building products, and I'm amazed at the people that have kind of the balls to go and say, oh, I'm going to build a product in Web3. Like, bless you, like, please do. But like, yeah, best of luck or whatever. So yeah, that's basically it.
So bullish and bearish. Mats, did you have thoughts?
Yeah, I thought that was interesting. I think one reason that we don't talk about is that how it's a lot easier to monetize a network than an application as well. Like, we could all spin up some chains and add some tokens in there, and it would be good for the core devs on that. But if you actually want to build an application, that's a long, hard grind, and the failure rates are incredibly high. And I think, yeah, as long as there's a problem there as well, I think. But yeah, my grandma can definitely also not bridge tokens and stuff like that. I think for better or worse, the users in crypto right now are somewhat crypto native at least. And I think we are starting to get applications that at least we know how to use. Before, we had applications that we didn't know how to use. Like, don't want to get into it even, but I've lost a lot of money on apps just not working and having no docs. And some person on Discord that works at the project doesn't even know how it works. So at least we're a little bit beyond that phase, I think.
Definitely a little bit better. Mats, I actually wanted to bring it back to you. So Dune obviously indexes L1, L2 data. How do you guys think about prioritizing chains and which you prioritize? And then how do you also think about your position in kind of enabling that ecosystem itself with Dune kind of as that layer to give people access to that chain?
Yeah, that's a great question. I think Dune comes from a very EVM-centric world. When we founded the company in 2018, there was basically only Ethereum and Bitcoin that was around that had any meaningful activity. And Ethereum was the only smart contract platform that actually worked. So a lot has happened the last 6 years. Now we have hundreds of smart contract chains, EVM, SVM, etc. And I actually think when we go beyond the L1s and the L2s, people building L3s, I think that's actually really interesting. There's a lot of people who are bearish on L3s and app chains, but I actually think it's kind of cool that you can build this block space for your application with the security guarantees that is necessary maybe for a game, which might be very low, but you maintain interoperability with the rest of the ecosystem through some funky bridges and whatnot, but at least you can still sort of move assets and do things with the same wallet and stuff like that. But the way we think about onboarding chains to Dune is really like, when we partner with them, we try to shine a light on what's special about that ecosystem and about the use case. Usually the L2s and the L3s serve some niche in the market. Some of them are generalist chains, but others have like, oh, we're a DeFi chain or we're a gaming specific chain. And working with them is always a little bit different, trying to showcase the differences. Yeah.
Very cool. I wanted to switch over to a spicy topic, which is, we've always talked about layer 2s as the way that Ethereum scales. Ethereum can't scale without L2s. And yet, a lot of what we debate now is whether Ethereum will actually capture the value that those L2s are creating, those L3s are creating. So curious how each of you think about that problem.
I can take that. So, I mean, first of all, most of these L2s do use Ether as gas. Obviously, ETH is cheaper on L2, so obviously it's not the same kind of network effect that you will get if you span, let's say, multiple Ethereum L1s. Obviously, that would suck. But besides that, there is obviously this matter of adoption that we would get by having increased block space, or at least we thought that we would we would get with that. As Matt was saying, like we have more block space that we know what to do with it, right? Like there is, obviously you have some chains that are, for example, as base, that are literally need more solutions to scale, like and as soon as possible because they're kind of at the top of the limit. But besides that one edge case, most chains are kind of meh, like they do have space, and they are themselves fighting for space to post their blobs or the data availability on L1. So basically Ethereum is not gaining a lot of money, but like having like some sort of income from having all of those data availability kind of events being posted on L1. But I mean, yeah, then there is this question of we will also get like scalability using L2s, but we might get scalability using different type of solutions that not necessarily would benefit Ethereum and might kind of cannibalize a little bit that, but that's kind of branching off to another direction. But
I'll just go actually because like I think when we introduced blobs, we created like the second market for Ethereum. Like before we had to settle using call data and that was very expensive, but at least everybody sort of paid a lot of money to settle to Ethereum. Now like there's a disconnect between how much it costs doing a regular transaction on Ethereum versus settling a blob that contains that transaction on the side. I'm not an economist, nor do I have the right answer to this, but it seems a little bit weird that it's that this arbitrage exists. But yeah, like I don't actually know the future. Like if I knew if Ethereum would gain or lose value, I think like probably wouldn't be sitting here. Would be on some Thai island instead. But yeah, I don't know. Can you predict the future?
No, I cannot. Yeah, I don't necessarily see it as like a big. The question was around value capture of Ethereum versus L2s, etc. I see Ethereum as kind of just like the slow-moving center of gravity or force that keeps all of the rest of the ecosystem together, which kind of means that it already does indirectly have all of the value anyway, right? Because if Ethereum stops working, what happens to everything else? So yeah, I think the way things are going is it's just going to continue to remain as so, and I see that value capture in L2s and L3s, etc., is okay, and as long as Ethereum remains that kind of center of force or gravity that keeps everything connected and keeps everything running in a proper way and in a secure manner.
That's a really beautiful way to end that question. I want to open up to questions from others. I see a hand over there.
Hey guys, thanks everyone for the panel. Harry, I have a question for you. How do you see Chainlink and, for example, CCIP integrating with small chains that, for example, let's say I'm with a team, a very small team, I have my own small chain, I want to integrate my chain to CCIP, how would I do it? And on the same note, I think, Matt, you released an integration with Conduit, right, to make this happen. I think that's great, so congrats on that. So yeah, how do you see the parallel thing with Chainlink?
Okay, right now it's kind of a convoluted process where you have to reach out to us and say, hey, we want CCIP on our chain, or hey, we want Chainlink stuff on our chain, and we have to integrate CCIP onto your chain based on resourcing and availability and stuff like that. So it's not the most scalable way, but if you take a look at our socials, you see we recently announced this thing called the Chainlink Runtime Environment a couple of weeks ago at our conference called SmartCon, and basically that's a re-architecture of the whole Chainlink platform, which enables us to really scale out to a lot more chains a lot faster, where essentially we've broken down Chainlink products into like core microservices, or what we call them capabilities, off-chain on our own platform, and integrating with a chain becomes as simple as us adding chain reader and chain writer capabilities for that chain. But then we don't need to deploy all the core smart contracts and things like that, because we move a lot of that off into what we call the CRE, and then the integration process for a new chain, no matter how small or big, is a matter of days as opposed to like weeks or months. So I think long-term CRE, you should look up that and see some of the info on that. But in the short term, before that's public, you need to speak to us to do that.
I have a follow-up on that. Like, do you see Chainlink being deployed as a one-click solution, as like with a conduit or whatever kind of these RAS providers do with other services?
Do I see Chainlink as a one-stop interoperability solution?
No, like a one-click install solution.
Oh, a one-click install solution. Yeah, a lot of people would say, you know, so you press one button and everything happens, but it's rarely the case. We spent a lot of work trying to make it as easy to integrate as possible and use. However, in the end, it's a pretty tricky and complicated thing that you're working on. Like sending messages and tokens across a chain is not like a trivial thing. And so I'm not sure if we'll ever get to like a one-click scenario, but maybe like in my opinion, like a 5-minute scenario is pretty good. If you can get to a wow moment, a success moment where you can integrate your service, use your thing, and it's successful and it works and the docs were correct, and then you can move on to your next problem. To me, that's something that's like a pretty good standard of DevX, in my opinion.
Is there any other questions? If not, I can follow up.
Yeah.
A follow-up question.
Can I ask a question to Eva? That's a graph. We're building projects on Solana, and we find out actually it's not that easy, or the graph is not so supportive on Solana. So we wonder what's the roadmap of the graph in terms of supporting Solana. Thank you.
Yeah, that's a great question. I think it was about a week or two ago, we actually just announced some work that PropellerHeads was doing. They spoke earlier today on creating custom substreams modules. And if you're not familiar, substreams are real-time streaming infrastructure to make it just much easier to get the data from higher block time chains. So Solana actually is not very well suited for subgraphs. And there's quite a few chains that are like that, but they're very well suited for substreams, firehose, and so that would be the solution. So actually, we've got some DevRel folks here that can talk to you about that if you want to learn more about substreams. Yep.
A question for Matt. You mentioned Dune is looking to work on more developer tools, assuming more advanced APIs, make it easier for developers to build apps. I think that's a super important role for indexers, by the way. Do you mind double clicking on that, like a little bit on the vision, and is, you know, also along the dimension of centralized versus decentralized services? Would be super interested in that.
Yeah, first to double click on the API side. So tomorrow's our version of this DuneCon, and we're announcing a new product that I've been working on recently, which is essentially developer platform with APIs that take data from all the networks that we support, not all of them right now, but a growing list, and make it easier to retrieve data from them in real time and put them into an application. So things like token balances, transaction history, wallet activity, stuff like that. And basically, we see it as an extension of our mission of making crypto data accessible, like to take that away from just being for analytics and be for building as well. And I think I lied a little bit when I said the UX is kind of good, because like the one thing that really pisses me off in crypto is that a page takes like 5 seconds to load every time. It's like you click a button and it has to do 150 RPC requests to get balances or to get like your history on the side. And I'm sort of on a like crusade against the 5-second page load. So we're building some APIs that are really fast that will hopefully solve that. On the centralized versus decentralized, this is an age-old debate, I think. The thing I heard the most in 2018 when we started Dune was like, but is it decentralized? And it's not, of course, it's centralized. And yeah, I don't know, I just don't think that's a problem. I think in the future we'll probably have ways to verify data using proofs instead of sort of like a decentralized network. And in the meantime, yeah, I don't think it's a big issue.
Am I still on? Yeah. Yeah, I just wanted to add, I agree with you, and I feel there's a tension between centralized data and APIs versus good and good UX. I am on the side of we need to build better products right now and focus on users and growth now, and I think that's an important problem to tackle. So
yeah, I think like even like making things performant in a centralized manner is difficult. Like creating APIs that return, I don't know, the wallet balance for a user across 30 chains in a centralized manner, that's like very hard to do if you just build it on one server. If you're somehow trying to decentralize that and fragment it across a network, it's going to be very slow. Or at least we don't have ways to make it very fast today. If you're thinking about a query engine like the one that runs on Dune.com, Dune SQL, it's sort of a distributed query engine that runs on our cloud platform. If you try to decentralize something like that, you're never getting a response to your queries. So I think there are just like practical trade-offs here, and right now at least, decentralization of something like that is a pipe dream.
Did you guys want to answer that? No? Okay, I think that's a great place to leave off. Thank you all so much. Thanks to our panelists.
The final keynote coming to you from Ayush Gupta. He's working on the PSC team, which contributes to the Ethereum Foundation. I'm really excited to hear about what he's working on. ZK emails for data provenance. Sounds super interesting. Let's give a warm welcome to Ayush. He's coming on stage.
Thanks. Okay, awesome, thank you. Maybe for me to just get a quick pulse of what people actually want to hear about, I'll do like a quick what do people know about? Like raise your hand if you know Solidity and want to talk more about different Solidity tooling or ideas. Okay, not a ton of Solidity fans. Okay, raise your hand if you're interested in off-chain data or getting data from kind of unique sources. Okay, that's much more people. Sweet, and then raise your hand if you're interested in kind of ways to make Ethereum or blockchain UX more comfortable and easy. Okay, similar number of people. Sweet. Okay, so maybe what I'll talk about then, I'll calibrate my slides a little bit to that. But basically, I'm going to talk about some of the ideas that we've come around for data provenance and data risks in the specific context that I've been thinking about in ZK email. I think Althea was originally scheduled to give this talk, and she was mostly going to talk about data provenance and data risk. So I'll try to cover those things for people who came for Althea's talk, but I give my own spin on it because of ZK email. So concretely, I guess, for the topic of how do you even get data provenance, the main way to do this is via digital signatures. We have this in Ethereum because when you send transactions, it's a signature, but lots of other things have signatures. Passkeys have signatures, passports have signatures. When you execute apps on your phone, you can use this thing called app attest and get a certificate showing that that thing actually executed, and then emails, which I'll talk about. So passkeys are intuitive because you get UIs that look like scan your face or tap your finger, and then things happen. And the reason that occurs is because you can get a signature and then prove that on-chain. Similarly with passports, if you can verify an NFC chip, the signature inside your passport, you can verify that on-chain and do things like proof of personhood. And if you get app attest, you can do something like, here's an app that is going to take a picture. I'm going to verify that your iPhone took this picture. And this is very interesting because this gives us data source that is outside of blockchain, but can be verified on-chain. And the really nice thing is you can combine this with ZK to get privacy. And so specifically to talk about this concept in the context of ZK email, I'll talk about proving existing emails, which basically lets you get the off-chain data that I was talking about, but much more widely because you can get it from any data in your email, how to get intuitive email-triggered transactions, and what this looks like in practice on mainnet. So concretely, what is ZK email? Well, the idea is all of the emails you've sent or received since 2017 have a signature on them. The signature is just an RSA signature of all of the data in the email that you hash together. Then what we do is we verify this inside of a ZK proof, and then allow you to selectively disclose what you do and don't want to reveal. It's quite interesting because it lets you keep arbitrary data private, lets you verify the data from any existing email server directly, and it lets you prove it directly on-chain. To kind of jog the imagination, one thing you might want to think about, the very basics of this give you something like, maybe I can prove a redacted email on-chain. But why is this interesting? Well, if you have this sort of data source, which is any email you've received, I can do something like build a domain marketplace on top of Namecheap. I can say something like, I'm going to send some Ethereum to a smart contract, and I'm going to pay for some domain in the real world. And basically, somebody can prove that they transfer that domain on Namecheap, use the confirmation email to unlock that escrowed money, giving you a decentralized marketplace that you've actually built on top of a Web2 service. It's quite unique because most of the ways that I've seen people interconnect blockchain and non-blockchain things has some central intermediary in the middle. Like you have to trust some third-party verifier between Ethereum and Namecheap, and that's very annoying. And the really cool thing is this isn't just limited to Namecheap. As long as you get a confirmation email of something, you can do exactly this kind of operation. And the QR code in the top right will let you literally buy a domain on Namecheap with Ethereum, which is kind of nuts. But you kind of want the ability to make new proofs, like say this Namecheap kind of proof, really fast. And so one thing we did is we realized, oh, if we want like 1,000 Namecheap marketplaces, then people better be able to make these proofs almost immediately. So for instance, we built this thing where you can go to our registry and you can define a new kind of proof. In this case, somebody tried to build a proof of DevCon rejection. Basically, you applied to DevCon with a talk and you got rejected. And the configuration is not too long. It's a little bit of JSON that defines, it better have a proposal title and it better say you were rejected and not accepted. And then you prove it came from devcon.org. And then we take this configuration and we compile exactly that email proof and let you build the marketplace or whatever you want on top of it. Folks built a lot of cool stuff with this. They built proof you received or signed a document on HelloSign/DocuSign. Proof you took a flight to or from with American Airlines to or from somewhere. This is quite cool because you can do things like automatic ticket reimbursement. You can prove you're part of a Slack workspace. This works for Discord, Telegram, whatever. Anything you get an email of, you can prove. And so this is quite cool because now you can move off-chain communities on-chain. You can prove you exported your LinkedIn data and then sell that to AI companies like OpenAI or Anthropic. And now they can verify, oh, yeah, they actually exported the LinkedIn data correctly. You can verify you exported your OpenAI chat data and then sell that to Anthropic. You can prove you completed some issue on GitHub, which lets you do kind of public goods disbursements automatically. You can prove you ordered a pad thai in Thailand. Somebody put this up with this code where you prove you got a grab receipt showing that you're in Thailand and you ordered pad thai. And of course, DevCon rejection. Now, another way that you might think about using emails beyond just proofs of emails you've received might be something like whistleblowing. So you can do something like, I prove I work at aztecprotocol.com, or I prove I work at boeing.com, or whatever. And the idea is, as long as you can prove ownership of that email address, you can now say something interesting. For instance, I work at Boeing, and I'm going to tell you which employee I am, but I forgot to put the screws on the door in the plane. And so now you can kind of have a way that people can express things that would normally cause them to, say, lose their jobs or might be higher risk, but they can do it with the full kind of verification of that source information without revealing who exactly they are. Now, the big problem with this, of course, is moderation. You can't allow people to spend the currency of the commons, or else they will then, you can imagine an individual draining the entire reputation of an organization by just posting hateful content. And so you can imagine that you could do moderation with something like a TEE, where you force proofs before they settle to pass a TEE verification that OpenAI has some credible neutral rules, say, this is not hate speech, and responded yes when you queried that API. And this is quite cool, because this means you can get credibly neutral moderation on top of message boards, and you can define your own kind of AI-based filter function. You can say, oh, I only want to see things that are not hate speech. Oh, I only want to see things that are not political content. I only want to see things that satisfy this or that. And people can curate their feed by that specific prompt, which is quite interesting when combined with the ZK proofs of provenance. And so another very interesting set of things you can do is you can trigger smart contracts on-chain with emails. This lets you do things like receive tokens directly to emails, have emails on multisigs, log in with your email on-chain, and do account recovery with your email directly to a smart account. OK, so how does this kind of thing work? Well, the idea is, because emails have a signature, that can directly trigger a transaction on-chain. You don't need to go through the whole process of fetching the email from the inbox, making the proof, and sending it on-chain. So how might you do this? Well, you can imagine you can authorize a transaction directly by replying to an email. If I have an email here, for instance, I've moved some data from the body to the subject so you can see it more clearly. Normally, this would be hidden in a div, but you can imagine that there is some sort of account code that links this email address to an on-chain address. This is not a secret key. This is kind of, you can think of it as a salt to a hash. So I take an email address, I hash it with this code, and then I get a smart contract which is controlled by that email address. And the email address is also private on-chain. You can try signing up if you use the QR code in the top right. It's very simple. You just hit sign up, you reply to the email, and then you have an email smart contract that you can trigger with arbitrary transactions. And the very cool thing is that because this account code is the only thing needed to make transactions, you can make sure the user doesn't lose access to that account, even if our entire proving infrastructure goes down. And finally, the actual process of receiving an email saying, yes, I want to execute this transaction, and then replying to it so it executes can happen in a totally decentralized way. It doesn't need to be us sending you that email. Anyone can send you that email, and any app can build this on top of them. And so this is quite interesting, because you can get this new data source, which is people sending emails, and use that to trigger directly on-chain transactions. In this case, something as simple as sending or receiving ERC20s. But you can do something, and in practice, it kind of looks something more like the email on the left, where you just reply confirm to accept the request, and the subject is kind of specified what exactly you're doing. Here, it's like accepting a guardian, that you're a smart account guardian. And on the right, you can see that you can also do this via just signing in with Google. You don't need to go to your inbox and reply. The security trade-off here is that if you use a JWT, you're basically doing this in a way that Google is signing everything, versus if you're doing it with the email, your own email domain provider is signing it, which may not necessarily be Google. Cool. So now that you can receive any asset to any email address, one compelling thing you might be able to do is basically send emails to send these Ethereum transactions and control smart contracts. The concrete flow looks kind of like you create an account, you put in your email address, you reply confirm, you get a confirmation, and then you get your normal wallet UI, and instead of triggering transactions to your MetaMask, it triggers it by sending an email and waiting for your reply. This is kind of maybe most compelling if you can have this be a multi-sig signer. So it turns out that you can, for instance, directly add an email address into a safe wallet. This hasn't been released yet, but hopefully will be out soon, kind of natively into safe. And this means that when you send a transaction from the EOA that owns the safe, the email can say, oh, if this transaction is over, I don't know, $1,000, I should probably get a 2FA confirmation. That email will automatically get an email saying, are you sure you want to confirm? They reply confirm, and now the multi-sig transaction goes through. You can try this live if you use emailwallet.org and safe.global on base Apolia. It's quite cool. You can basically take the address from this screen and put it into any safe as a signer on base Sepolia, and it'll just work. And one of the cool things here is that we have to index basically the blockchain events, both happening with unconfirmed safe transactions to know when to send emails, how to send them on chain, and to know the state of the safe on chain. And so we have to use kind of any on-chain data indexer like the Graph or Shovel or whatever for that. Sweet. And when you think emails on blockchains, you might think login. And so that's exactly what this sort of thing also allows you to do, is reply or sign in order to log into an account. So you can do exactly that. This gives you this kind of ephemeral key-based transaction logic where now your front end can send transactions on behalf of your email with some scope, which is kind of the ideal flow. Like you want users to just hit sign in, not think about it, but to not access all the assets in their wallet, which is I think quite compelling for general crypto security UX and for getting the UX of people interacting with wallets to not look like connecting MetaMask, because that's a huge barrier to people beyond the 20,000 total people in crypto to actually use the apps. It's easy to integrate. You get an email that similarly looks intuitive, and it's totally possible to integrate today. And the final thing is, you can imagine you can use emails as guardians to recover your account. If you have this other data source of emails replying, then this is very valuable for security on your existing smart wallets. So you can imagine, for instance, that this is one of the most important things when you think about kind of wallet screw-ups being the reason that people lose most of their funds on chain. So concretely, what you can do is, on top of any safe account, on top of any 7579 account, aka a smart account, you can basically add emails as recovers. And the ideal use case here is something like passkeys, where users, again, it's invisible. They just do Face ID or tap their fingerprint, a transaction goes through, and they just use an email to recover that account. And so concretely, you'd imagine that users would say, OK, I want 3 guardians, and I want a time lock of a week. Subsequently, they would add the email addresses they want to be their guardians. The guardian would confirm that they want to, in fact, be a guardian, and that way you know that they didn't typo the email. When they actually lose their phone, or their passkey, or their wallet, or their ledger, or whatever, then to recover their assets, the guardians will all send a recovery request like, hey, I want to recover my wallet from here to there, and then a time lock will start. Once the whole threshold is met and the time lock finishes, then the account's assets will get recovered to the account that the guardian said to recover it to. And this works exactly the same way that all the other previous flows worked. Something gets configured via front end, the email gets an email, they reply to it, and a ZK proof is generated, and that proof is verified on chain. This happens both for guardian acceptance and for actually processing the recovery. It's the exact same series of steps. And you can try this live, prove.email/recovery. Basically lets you recover any safe account on, right now on base Sepolia, but soon all chains, with exactly this kind of flow. And it works with any existing safe or a new safe. And we're really hoping that by enabling these kinds of new ways to use off-chain data, that it enables a whole new way of interacting with blockchains. And so hopefully, to make this easier for people to use, you can kind of have this generic interface where people define a simple Solidity smart contract, then call an API, and they can build their own version of account recovery or email trigger transactions or whatever it is. I've just presented 4 examples, but there's so many more things you could do with this. Sweet. And if you want to see, hear, or read more, you can see my Twitter, USG. You can see our website in the middle, zk.email, and you can see the slides on the right side. Sweet. I'm happy to take any questions if people have any. Cool. I'll call it there then. Thank you.
All right. Thank you. Thanks so much for jumping to sub in for Althea, and really appreciate you sharing what I think is a really interesting new use case. So really cool. Thank you.
Cheers.
Thank you so much. Alrighty, guys. As we wrap up Datapalooza, I think a couple of shout-outs are in order. I want to thank the Graph Foundation for organizing this. I want to thank the production team for keeping things going. And a big shout-out to the audio-video team who's been working all day. Final shout-out is you guys in the audience. Thank you so much for coming to Datapalooza. I'll see you throughout the week at DEF CON, and I'll see you next year at the next Datapalooza. Give yourselves a round of applause. Thank you so much for coming today.